I don't know, but Eve is kind of hot, dude.
Oh, it's not fair, really. I mean, Snow White's probably just as hot, but she's not. You know, Eve's not wearing a shirt. So
Yeah.
sort of reeks. She's saying I'm hot, but you don't
Yeah.
really.
She's just flaunting it out there.
I don't know. Snow White's prone to just lay there until you bust out the apple. So maybe
She doesn't seem like much fun, Snow White, huh?
that's where I went for the witch. I'm all, dude. I went to the witch. I'm like, Snow White's just laying there, man. What can I do? He's like, give her the apple, dude. But the snake said not to do that. Imagine the argument at this table, right?
Did
that Bill Gates on the end? Who is that?
Yeah, or Jobs or Gates. Steve Jobs, probably. It's the other end that I can't figure it out. It's got to be
Robin Hood. Who the hell is
It's
that?
got to be Robin Hood. It's the only thing I can imagine, and that's just because of the hat. So the last one is the one next to the witch. Was it William Tell's dad's girlfriend?
I also don't know who the who the other guy is with the green shawl on, kind of fat looking kid.
That's William Tell's kid. So on the other side of William Tell is the mystery. You'd think it'd be easy since we're on the path, you know?
Well, he's
Anyway,
got like
this is topical. You were asking about apples. There you go.
Yeah.
How do you like them apples?
Yeah, tomorrow you got to watch out for like candy apples with razors in them, apparently. So I don't know if that's ever happened, but they say it happens.
Yeah, I used to go door to door, not worry about it. But if you really think about it, in the movies, we accept the bad guy. In real life, we don't want to think that somebody up and down our street might be a piece of crap or even evil. You know, the idea that if there's 10 houses, there's probably one of them houses that's full of pretty dark energy. It's also weird that there is that there is good and evil. So evil must be necessary. Like as far as the adversary, you know, and so you have adversity. Otherwise it wouldn't exist. So it's kind of weird that it even exists. But we don't like to think of it on our block. We kind of dig it in the movies where there's a bad guy, but on our block, you don't want to think about that.
They're not dark energy, they're dark matter.
Dark lives don't matter, Jace.
What bigotry are you spouting?
Physics lives matter.
I was getting a chuckle earlier. It's funny.
See, I've written a flat Earth joke. Let's see, where is it? Okay, here's one. This isn't very good though. It says, my girlfriend Emily is into worship of the sun and she likes it in the butt on the summer equinox. I call her Anal Emma.
Okay. What else you got?
I'm looking.
You making them up, or these are something somebody else made up?
I made them up, but I wrote them down. I've got like a chat fodder text thing, like a go-to text crap. Okay, so An earthling, an earth mathematician, and an earth geographer walk into an earth bar. The city and the country are not relevant. The bartender says, "What do you have?" They say, "I'll have an 8 inches per mile squared." And the other guy says, "Make mine quadratic."
I get it.
Isn't it quadratic?
I hope not.
Okay.
You already wrote it down. There's no writing it down twice.
Is it quadratic?
I mean, I don't know. I could be wrong, bro.
Don't make me look. Don't make me be right.
Quadratic.
Speaking of evolution, I just got to see this commercial here. It says 99% of people who have shingles, who get shingles, already have the virus within them. No evolution needed. It's already there.
Disproven.
Yeah.
It's all the thousands of evolutionary biologists should just pack it up and go home.
Where's a mutation when you really need one?
Right?
They put a
Pack it
disclaimer.
up, boys.
The Globers put a disclaimer on me. They said I'm for entertainment purposes only. Just like the Globe has that disclaimer sticker.
Does it though?
I heard your boy.
Decorative ones do.
I heard your boy Dan Curved in Geos. He said the other day, or was it yesterday? He said if you put helium in a vacuum, it would go to the bottom. I couldn't believe he said that. He said if you put helium in a vacuum, it would go to the bottom.
I wonder why he would even say that. That doesn't make a lot of sense.
You think it wouldn't?
I think that gas moves in all directions in a vacuum to fill the
Like
vacuum.
a helium balloon, or
He said helium. I think the balloon latex will go to the bottom.
yeah. Obviously, if you have helium with a whole bunch of energy and you just put it in a vacuum, it's going to spread out. It's got a bunch of energy. If you cool it down, though, like sometimes for NMR, we use helium that's just above absolute zero. That stuff's not going to spread out.
Well, I mean, you're saying it's a solid?
No, but you can't violate thermodynamics. It needs energy to move. Movement requires energy. So it'll have little movement, but it's not going to just disperse like gases at room temperature do.
Interesting.
Yeah, that's what a lot of people get that wrong. They assert that gas can just move without the use of any energy. That's not correct. That violates thermodynamics.
It's hard to come up with jokes, Dan. I mean, I've tried like once or twice before. I came up with one joke. It was kind of relevant to the good and evil, but it's the only joke I ever came up with. One joke.
Let's hear it.
Nah, it's more of like a lesson, but of like how to figure out like if you're doing the right thing or the wrong thing. It's more like a lesson, and then you figure out like if there's a joke in the end. It's like, I think I might even have told you like the lesson before, like the way that you can figure out whether you're doing the right thing or the wrong thing is that like every single time you'll come to like a fork in the road with a decision, and on one side it's going to be real easy, right, and the other side it's hard, right? It's going to be a hard choice, and you'll know that the hard choice is the right choice because I've gone through like hundreds of different like scenarios in my mind. And every single time I get to a fork in the road, and on the one side, it's got like an easy decision, right? And on the other side, it's like a difficult decision. And the way I know that the difficult decision is the right decision is because I went through like 100 different scenarios in my mind, and every single time I came to a fork in the road. And on the one side, it was like an easy decision, but on the other side, it was a difficult decision. And the way I know the difficult decision is the right decision is because I went through like hundreds of different scenarios in my mind, and every single time I got to like a fork in the road, and it just goes on and on, Dan. It just doesn't end. That's my joke. It just goes on. I could go on for like an hour with that same joke and never get to the end.
I forgot the quadratic punchline was actually from 3DP. My punchline was different. I said I'd like to have a radius. The other says I'll have some curvature.
Don't blame him on your mistake.
Well, I'm just asking which is the better punchline.
He's a damn genius.
Where's the punchline where's the punchline when you need it? I like telling a punchline and seeing if people can remember the joke.
You had a geography and a mathematician earther in a bar.
Okay, well, that's based on my story called Two Earthlings Walk Into a Bar. I decided that Earthlings were worth making fun of. And I wrote like a short story, like a movie kind of thing called Two Earthlings Walk Into a Bar. Imagine how we see aliens as being like overlords, like they've been watching us develop for years. Let's say that they just stumbled into us primarily because of television broadcast. So they show up not to help us or to do anything else, but they want to be on TV, right? So they do the circuits. They're on Conan O'Brien. They're on, Jimmy Kimmel. They're on all these shows. And they explain how they're from space or whatever, and that there's all this no more war because of humor, because they've replaced it with humor. And they think they're very funny, but as we watch them, it's very shtick. It's very Three Stooges. It's very slapstick. And after a week or two, everyone realizes they're not funny. They've been on all the shows, and they stop getting bookings because they're literally stupid, right? And
it doesn't matter though, Dan. It doesn't matter.
no, it does, because they suddenly look at the Earth for the first time and realize that we're pieces of shit destroying the Earth and that we need to be eradicated. So they go, look, so we're no longer entertained. We had overlooked it before, but you're destroying what was a Garden of Eden, and you got 2 weeks to get your shit together before we eradicate this place entirely, and start over. And so the panic sets in, and everyone's going nuts. And the hero, the Jeff Goldblum doctor character guy, develops a theory to tell him about our iron core. And he makes up a theory about irony and how they have humor all wrong, and that they need to develop intellectual humor because this slapstick shit is just physical comedy. So we give them this whole pitch that the reason why we're ruining the Earth is because we have an iron core, and we understand the irony of ruining it, because that's intellectual humor, irony. And he saves the Earth. They go off with
God.
intellectual humor, and we save the universe from slapstick comedy.
Listen, I don't know how DP is doing. I know he is going through like some health issues, but if he's feeling better, you might want to reach out to him to help you with this joke.
Right, but the movie's a good idea still. The movie's
Just a flat Earth movie would be a flat Earth movie would be cool. Period. Like, it'd be badass. It was just Star Wars, but in reality.
Dude, it'd be modern day Dungeons and Dragons. I could write that script. That would be awesome.
Yeah, I was watching Lord of the Rings the other day, and I'm like, man, this is all on a flat Earth. You know it is, because the eye of whatever his name is, he sees Frodo, however far away. If the Earth was a globe, that it would be blocked by curvature, but he can see Frodo from his mountaintop. So this is, that's how you know. Like Lord of the Rings is based on a flat Earth. That's badass.
I want it to be more like Galaxy Quest, where like Mark Sargent wakes up, he's really in charge of everyone. David Weiss is his nemesis. trying to take over. You could have like everything became real, right? Like Galaxy Quest. It is a flat Earth, but there's no peace on flat Earth because we continue to fight over it.
Stop it. Yeah, no, flat Earth. I mean, there are some like I said, like Lord of the Rings seems, like these are like realms. Like they don't, they tell you like this is a realm that we're in, and there's different realms. There's no even like Mortal Kombat. It's not like I mean I think it is now, but it used to be like a flat Earth. Like the cool stuff is done on a flat Earth. Like
Flat
with
round.
yeah. Yeah, I think maybe even in SG-1, they just don't know they're on a flat Earth. They're just going through the Stargates and not realizing that they're just going to a different pond. And when they go up high enough in their little spacecrafts, I mean, they have a circle of light from a local sun, and they think they're on a planet. You know,
Come on, Willis.
yeah. Well, honestly, a lot of the cool shows are like flat Earth.
Like
Was
like
Z
the
flat?
honeymooners. Remember honeymooners? He'd be like, "One of these days, Alice, boom, flat Earth."
That's kind of funny.
Right to the flat Earth.
Yeah, that might have been your best one so far, Dan. That was pretty good.
Why I gotta.
Like all the vampire movies and shows, right? Like, could you imagine being a vampire and then like on a globe? That's ridiculous. What a ridiculous idea. A vampire on a globe? Like, come on. Like, it doesn't even make
So let's
sense.
hear this.
No, it just doesn't even make sense. I'm doomed to an
Yeah, you gotta
eternity.
elaborate.
Well, like, you know what I mean? Like he's doomed to an eternity. He's just he's dying in a swamp with the one guy in the one interview with the vampire. But all this time, and they don't just make spaceships and like get the hell out of there. But no, yeah. The sun somehow is killing them, right? But they live on a globe. It doesn't make any sense. Yeah.
I don't know, man.
There's no vampires on a globe. Their story would not be. I mean, really, could you think of like how dramatic like a vampire's life is? It's like dramatic and sad and like carnal, right? But not on a globe. It's not. Like it's just like, dude, you're just a little speck of vampire on a globe. Like you don't matter. It doesn't matter if you're eternal. I don't. How could you feel bad for that vampire? A werewolf? Werewolves getting turned by our dusty rock, reflecting sunlight? Like it doesn't make any sense. Where you can't have werewolves on a globe. Yeah, all the cool stuff comes from a flat Earth. Vampires, werewolves, Lord of the Rings, Eye of Sauron or something.
Oh no, thanks. You kill me, man.
It's,
Kill me. You still on the James Tour bandwagon?
me?
Yeah,
On the what tour?
the James Tour.
What's the James tour?
Never mind then, I guess.
Yeah, I might put my mind to trying to come up with another joke. That first one does work sometimes. It's more like a troll joke, though.
I accidentally came up with a joke. I was trying to come up with a good idea. There's two good ideas I have. One is to make a dart game, kind of like Around the World, where you start.
It's not a joke, though. It's not even a joke. Like the last one was a
I haven't
book,
gotten
and that
there
was
yet.
the game.
I said I accidentally came up with a joke while I was working on two different games. One was a dart game. I'm sorry, dart game, and I hadn't really developed that. And then I thought, well, cards is another thing that we could sort of hijack into a flat Earth game. Like instead of Crazy Eights, it could be called Flat Earth 9, right? Something like
Right.
that. But adapting cards and darts to a flat Earth game would be a great idea. So I went further and I thought flat Earth basketball, right? So here's how flat Earth basketball is played. You dribble down there, and just before you're ready to shoot, you argue with your fellow players until the other team takes the ball and they score.
The court is flat, though, Dan.
Yeah, but it's fucking hard to play. This game is fucking hard to win at. I'm telling you. Flat Earth basketball ain't your best bet for a winning season.
I mean, I guess they have globe football with Neil deGrasse Tyson. So I don't know if I'd want basketball to be mine, though. I mean, hockey maybe. You could throw hockey in there. There's no loyalty in basketball anymore. These guys just go from team to team,
Yeah.
whoever pays the most. In basketball.
I'm trying to mix hockey with
Y'all
other
got
sports.
Kyrie and Shaq.
I'm trying to mix hockey with other sports because you're allowed to fight. I think chess and hockey be cool. Golf, if there's a dude on the green trying to keep you off the green, that'd be kind of interesting. Little hip check.
Yeah, well, golf, you would definitely need to account for Coriolis, which, if you ask any golfer, they do not account for Coriolis.
Just think there's not enough defense in some of these games people play. Bowling, right? Some asshole keeping you, from trying to shoot. That'd be cool. Besides, I can't believe they just can't do that 10 times in a row anyway. How many times you got to do it in a row to get a perfect game? How fucked up are people? They just can't do something 12, 15 times in a row? Jeez. Imperfect fuckers. Breeders. They're just breeders and shitters. We poop a lot. Eat, poop, sleep. Weird machines. Okay, so imagine a place full of robots. And instead of like us inventing robots now, they invent biological creatures, and they're all worried about them taking over.
Clones.
What if this is a cycle? Like Planet of the Apes, for real.
Like Dallas David says, clones.
Planet of the Flat. That's how we could make they take off and they land on a flat Earth. That'd be fucked up. They have to tell everyone that it's really a globe.
Planet of the Flat. That's pretty funny.
And do you guys remember the original Star Trek with Kirk? This 5-year mission that they said at the beginning, a 5-year mission to boldly go where no man has gone before. This guy would fuck anything. Kirk, it's like, yeah, she's green. She's made out of rock. She's fucking styrofoam. He didn't care. He went for it all. So what if you took your standard format like Alien, the movie Alien, and you have this thing on board that's a threat, but you use Captain Kirk and he's trying to screw your women.
I got a
He
joke
acts
for you,
all
Dan.
innocent, going, "Wait a minute."
I just made up a joke. I got for you. Ready? All right, Dan. How do you tell a flat earther that they don't live on a globe?
How?
Man, see, if you didn't even understand that, that's what I'm thinking. How can you?
Is that the
How can you
joke?
pretend to? Yeah, how can you pretend to
Already a
understand?
joke?
And
I missed it. I think you should work towards knock knock. Like knock knock.
let me go to knock knock. I'll be right back.
A glober, right? A glober who? A glober who spends his life
A globular glob.
attached to flat earthers, pretending that they have a life. I've been talking to the globers about that. You know, they really are part of our community. They really are stuck with us. Like they're tighter than us. Really, that's the weird part. Like they've got something to rally around. They've got something they think they got to prove.
Well, it's
So
not
they
that you hear. They'd say, Globers will say, "Well, what have you done? Like, what has the flat Earth done for us, right?" Because like, what is, what do you produce you with your flat Earth knowledge, right? Because the thing is that Globers realize that there's something wrong in the understanding of what we have, whether no matter what, right? And they're saying like, when are we, they want to see some progress. They know there's something wrong with the understanding of I don't know, light or gravity or whatever else they want to bring up. They know there's a problem. We can't get the mainstream to like kind of bend, and they ask the question, what have you done? Meaning, what have we done? What can we do? They want to do something too.
I got them to get honest earlier, and they were saying how much they'd learned from us, and how surprised they were every time that there was something to learn from the
Most
flat Earth.
most globulars can't even get the globular theories correct.
So they got humbled, and that's why some of them stuck around, and that's why they got triggered as well, because they didn't want to stay humbled. They wanted to prove us wrong. So that's why they're so staunch about it. They hate being humbled with the shit that they thought they knew all the time.
Most of them don't know much, though.
No, but they think they do. That's the problem. They're willing to argue points they don't even. They really are. They really do. Shit, did
Yeah,
I
I
post
hear
that?
you.
Too late. I didn't mean to do that.
I was at Jim's the other day, and I had some fellow globulars, all sorts of confused about particles and photons and chemistry, quantum mechanics, all hashed up.
All right, Dan. How about this one? I got another joke I just wrote down. All right, how does a glober and a flat earther have a conversation about the current model? They chop it up. Get it, like conversation, chop it up. Okay.
Nice.
It was not funny.
Back to the drawing board.
It was kind of funny.
It says the Glober.
You want to hear some scientific?
globularity.
You want to hear some scientific doublespeak? It's a short video. It's too funny. Have a quick listen.
It's contradictory, right? Science is usually done in literature, not in videos.
No, but you got to listen to what he says. He's a bigwig.
Who is it? What does he say?
I asked him if space is fundamental. And he said, well, it depends on the day. Listen to it. He goes, well, yeah, no, well, yeah, no, well. Yeah.
Well, he's probably just deciding how much minutia he wants to go into, if it's worth it or not to go into the minutia.
That's a smart
Yeah,
guy. Yeah, well, you got to be
I'm
smart
sure
to
that's what
understand.
it is.
I know that's what I would be deciding if somebody asked me that. I would evaluate, well, what's their base knowledge? What would they be able to handle? How much minutia should I apply it on?
Would you say depends on the day?
No, that's
But he did.
rather silly.
No, that's why I posted it.
Let me guess, it's Neil
No, what's his name? That other short guy.
Baku.
No. Jewish guy.
Kraus.
Yeah.
Yeah, those guys haven't done science in decades, though. So.
But it's funny to hear them talk like that.
Could be.
Yeah, it's like Neil deGrasse Tyson isn't smarter, but it's like pound for pound, he could probably kick everybody else's ass. That's why he leads the pack.
You're talking about nerds, right?
Yeah, Lawrence Krauss needs help tying his Velcro shoes.
Possibly.
Not like Dr. Stephen Greer. That guy looks like fucking Jack LaLanne. Hell, it's a good bodybuilder.
Guth and Glasgow.
But if like a real scientist looked like they were like in really good shape, you'd like wonder if they were spending enough time in the lab. They're just working out.
That's funny. I run like almost every
Dude,
day.
so much of getting in shape is just eating right. Like if you eat good, you don't get fat.
Check this video out, man. Surreal. 1897, Israel. Jerusalem. Very short.
Yeah, it is weird to think about Captain Kirk and his romantic tendencies. And the social modeling that really laid up on us.
Kirk Dirk.
It's like somewhere in the distant future, like free love makes a resurgence, but it's applied to interspecies. Extra species? Extraspecial.
Extraterrestrial species.
Seek out new life. The new hookups.
You say extra testicle?
Extra testicle species.
Right.
Extraterrestrial.
You'd be hooking up with like an Andorian chick with antennas,
Nice.
blue skinned.
I think the chick with the 3 boobs from Total Recall was probably the best alien species yet.
It's not a species, it's a mutant.
All right, there, Mr. Fucking Smart Guy. I don't see X-Men having no tits, so I don't know. I call that an alien, bro. I don't know, man. Closest I've come to 3 boobs was Kosho's mom. She's got that beer belly with that extroverted belly button. Kind of looks like a 3rd boob. Just saying.
Damn.
You went all the way down the road for that one.
No one was saying shit, bro. I had to take it there.
You walked that one back.
Now lean back.
If I was younger, I probably would have made like a Kosho as Kotho from Total Recall. You know, like the little tiny guy that lives inside the other guy's stomach. Meme. But I'm.
Oh, that's
I'm
Quaid.
No, Quaid is Quaid.
That was a classic part of the movie, huh?
Quaid is Quaid, but Kotho is the little guy that lives in the other guy's stomach. The rebel leader. Spoiler alert.
I'm pretty sure that was fucking Quaid, dude. That little fucking head that popped out of the dude's
Quaid.
chest or
Quaid.
stomach or whatever.
Quaid is Arnold Schwarzenegger.
I think you got your shit all fucked up, man.
He's his own double agent. Carl Hagen, I'll get you. He'd say.
That's pretty good, dude.
Thanks. I was feeling it. I always feel like Glober's like that creepy guy from Total Recall. It's like we need to take you back to Recall. You're gonna have a schizoid embolism.
See if we get any Total Recall gifts here. See what I got.
But then the Glober's got like a bead of sweat trickling, and you know he's full of shit, so you waste him.
Oh, here it is. This is the little dude you're talking about.
You gotta watch that scene again. It's so corny. It's so bad. What the fuck?
Fucking great movie, dude.
It is. I like the get ready for a big surprise. The head that blows up is so good. The effects are awesome for that.
Oh, when he's got the fake head on in the supermarket.
Yeah, that's just
Big
awesome.
fat chick. Yeah, it was pretty cool.
Yeah.
Movie was like way before its time, dude.
Johnny Cab. We need a Johnny Cab.
Fuck yeah, with that long ass fucked up weird arm.
Somebody ought to make a fucking Johnny. Somebody will actually make a Johnny Cab that actually works.
Oh, you're saying like the car itself?
Yeah, like the fake guy had. And, hi, I'm Johnny Cab. You know.
Oh, you're talking about that one. Okay, I thought you meant the black guy.
In 10 years,
I got
Johnny
8
Cab.
kids to feed, man.
Oh, yeah. What's his name? I got 8 kids. It's got like a weird grasshopper arm.
Yeah, bro. It's like a fucking praying mantis looking fucking thing.
Yeah. Yeah. That's right. What kind of fucked up mutation they take you for, you know what I mean? Like, you know what I mean? Like, yeah, mutations like the 3-eyed fish in The Simpsons, or a 3-boobed woman, or guy with a praying mantis arm.
I don't know, dude. I'd probably would have taken the grasshopper arm over the fucking vagina on that one dude's neck.
Like, from what kind of pollution is that even happening? They're on Mars. You know what I mean?
Vagina neck?
What? And there's the bartender with the fucked up eye thing. Oh man, what a good movie. It should have been a sitcom. Like Cheers.
Friends, bro.
Me and my friend had a theory that it was really that they were just trying to mnemonically program you with France, and it's friends and friends. You got France. I got France. I got friends in France. You know what I mean? Get all there because it's Eiffel Towers in the background and the Rembrandts are playing.
You guys talking about the guy who overdosed in the bathroom?
Well, we weren't actually trying to take it there. It's a little too soon for that, but yeah, thanks, bro.
Yeah, you kind of rushed ahead a bit, but yeah, go ahead. I was trying to keep it topical.
Oh, sorry. Yeah.
Why don't you go ahead and slave for us?
So I don't know if you've heard. It's very sad. Chandler's passed. I don't know if you've all taken a moment already or not, but he just came out with a book too, sadly, and about how he beat addiction. And he wrote a whole book, and then he was on a TV show crying about it, and as it just like kind of pulled from his from his soul how he beat the addiction, and then sadly he died alone, like many of us will, just alone, overdosed. Just that addiction just took him back.
What was it actually that he was addicted to?
Wait, don't interrupt. He's got a punchline. Hold on.
I don't know.
Yeah.
No, go ahead. Go ahead. I'm still working on these jokes.
Souls.
Talking about movies, have you seen Peter Jackson? You know, the guy that did Lord of the Rings, right? Lord of the Rings. Yeah, you look at his earlier work, he's got 2 movies that I encourage you to go and watch with like a big doobie or a bong. One's called Meet the Feebles, and another one's called Brain Dead. Both of them are just B-grade classics. And Meet the Feebles is done with like stuffed toys and puppets and models.
The same guy who wrote what? Lord of the Rings?
Yeah, Peter Jackson. Yeah, Lord of the Rings. He did Meet the Feebles and Brain Dead, both filmed in Wellington, New Zealand.
Not like a parody, but the actual Lord of the Rings?
Well, the guy that made the Lord of the Rings movie, yeah, that guy.
Hmm.
Peter Jackson.
Adapted it for screen and directed it and produced it.
You can still get them on VHS tapes.
It's crazy. Like, he didn't seem that talented, like, given on his early films. It's like if Kevin Smith got the Lord of the Rings franchise, you'd be like, oh, what? How did that? I don't know.
Yeah, that's
Like that.
exactly. He doesn't seem that talented. Yeah, so someone else has stepped in and guided him along the way, I'm sure, because yeah, he definitely doesn't look clued up enough to make the movie Lord of the Rings.
He started from he started like as an indie filmmaker and then builds a basically like a multi-$100 million special effects company and Wingnut Films. I mean, what the fuck?
I think the company he was using was a
No.
company called Wetaworks.
Yeah, Weta. And then Weta Digital, and then fucking Weta just got bought by fucking Unity or some shit for like what kind of money? Like unbelievable, crazy. And then after he did Lord of the Rings, then he does District 9. But with that movie was supposed to be Halo, but they shit canned the script, so they had to like basically bullshit the
Halo.
script. They had all the special effects and everything like on standby. They just lost the project, but they had all the people like already there. So that's how District 9 happened. Crazy shit. There was like no movie making down in that part of the world before that, really, or nothing. Nothing. Yeah, I can't name like a single New Zealand act like a TV show or anything. I have no idea. They have TV. It's like
Yeah,
Sheep
we
Channel
have.
1, Sheep Channel 2, Sheep Channel 3.
Yeah, it's kind of all local stuff, really. Nothing that you could really point out to be international. There's been a few big hits, but they're all sort of just. I think they make their way over to Australia. That's as far as they go.
Why is it all quiet? Jeremy doing another prayer session or something?
And my brain just like hit the wall, like in Snake or something. It's just over. I don't know. I don't know what happened. Yeah, Jeremy wasn't helping out. No thanks. How's your rework of the Matthew Perry joke going? He's deep in thought.
Witsit is doing a debate tonight versus T Jump.
I was just going to say, how about the picture of that church I just passed? Got that big ass Tartarian style window on it. Big portal. But yeah, go back to your Witsit thing, yeah.
Oh yeah, it's a modern day debate. The modern day debate stream in about an hour. Dang, dude, that window's crazy. Yeah, dude, like I don't know. Lots of mysteries on this planet.
You know what is funny about that church? That church looks like it has been carved out of a brownie. Or chocolate fudge brownie.
It's
or
like
chocolate cake.
it's the chocolate gingerbread house.
Yeah. Like really, man, it looks like you can just go to it and just bite some piece of it.
I know, I'm hungry. It's making me hungry.
I got another joke I just finished writing. You want to hear it?
Shoot.
There
All
was
right.
a globe.
Why did the hypersexual woman marry the flat earther? Because on a globe, south is only one direction, but all directions take you south on a flat Earth.
It's pretty
No
good.
good.
Too bad.
As a German, I'm too stupid to understand that.
I mean, she married you because you go down on her better than a glober.
I'm just gonna pretend as if I got it.
As a virgin German,
That's
he
funny.
doesn't understand that.
Exactly. How do you know? That's just a typical German.
I
But
got
you have
potential with this one here, but it's not going anywhere. I got like the story plot, but I just can't figure out a joke. Two flat earthers get a free ride on the ISS. They can only bring one item each due to the weight. I got all this stuff going, but no joke yet. I gotta figure that out.
But the Germans have secretly conquered the whole world, you know, or the lineages of German people. Which is kind of sad because I don't understand why so many German lineages are so corrupted and mentally ill.
Yeah, you can get a lot done when you're not focused on sex.
Your joke could be on the Glober that goes along with the two flat earthers. Like, I don't know, maybe he brings something irrelevant.
Yeah.
Like literally. Germans are responsible for 9/11, for JFK, for all the major weapons, for the globe lie. Isn't that ridiculous?
Well, they do say that it costs a lot of money. Every kilogram that they take up to the ISS costs money, and you know they're taking stuff like gorilla suits and fucking guitars, all sorts of shit. Probably cost $100,000 to take that guitar up there.
I mean, it's not going anywhere, right? It's just a Ponzi scheme. There's never been a guitar up in the heavens.
Hey, dude, global warming, right? Like, every pound of CO2 counts, right? But let's bring this gorilla suit up there.
What I don't understand is this, okay? How is it that there's men out there that have gathered so much money and influence and power that they're not saturated, or at least come to a conclusion that no matter what they do, it will never satisfy them? Like, I mean, it's, at some point you just gotta realize no matter how many mansions, no matter how much control and influence you have, I mean, it's obvious that it doesn't satisfy.
Where's the punchline, Clay?
Nowhere. I'm just wondering how, Yeah,
I got a flat Earth joke. You guys want to hear it?
Yeah.
the Earth is wrong.
You know why Globers are obsessed with the globe?
Why?
Because they're gay and they love balls.
Well, that one I understand.
I know, it was really bad. My bad. Dude, I still I still think that Taboo. I posted it forever ago and I kept having to go back to work, but that Taboo conspiracy with when the pilot's flying against the rotation of the Earth and the stars don't move at all, isn't that just so good? Like, what do you guys think of that? Did you see it? The one I posted?
Nope.
Oh, here, I'll post it again. It was really good.
Let me ask you guys a question. Can the moon ever appear to be under the horizon?
No, there's no way that would not make sense at all.
No way, right? Okay, hold on to your hats. Upcoming video. It's a short video. Tell me, what do you think? You
The horizon is an apparent position. A mirroring of the sky and ground.
Yep. But looks freaky, no?
Mm, it kind of looks like a ship floating in the air. There's no difference in a ship or a building appearing to float in the air than a ship or a building appearing to be below water. You know the sky and the water in the foreground is making that effect.
Yep.
We know ships don't float in the air. We know they don't float below water.
Cool video though.
Yeah, dude, that like just like again, does that, there's no how is that explainable? You know what I mean? Like that's
Well,
just
Rakia just explained it.
Yeah, what appears to be the ground rising up towards eye level is above the moon. We know that's not possible. And or the moon can be projected or appear lower than what it actually is. It just depends on what effect you're viewing. When anything's not reality, not as you know it, it's an optical illusion.
Exactly. There's probably a mathematical equation explaining why it is logical on a globe. So I would just refer to that, even though I've never looked at the equation.
There's definitely a mathematical equation involved. There has to be.
Yeah.
dude, math is reality. It's just math is reality.
Exactly. Only stupid flirts don't understand.
Dude, so that the one I posted, it's like I forget how long the flight is, but the guy is flying. It's like the GoPro in the cockpit, and the pilot's flying against the rotation of the Earth, and there's not a single degree change on the stars. They're just regular. Like, dude, it's like how does a Glober explain that? There has to be some kind of star, like the degrees of the stars would change as you're going around a globe. Like the fact that they don't change at all, like that to me is like, how do they refute that? Like, does it make sense to you guys? Like, isn't that just like that one gobsmacked me? Like, no way.
Well, no offense to anyone, but you know you're not on a globe, right?
Yeah, I mean it's pretty obvious. For me, that's pretty much game over, dude. Like the flights, there's no degree changes, and then on top, and then Allen's work with the laser interferometry that they just cannot even address or talk about, or they just flat out lie about it. Like that for me, it's just like it's over. The globe would have to do a lot of things to try to convince me otherwise. Just obviously a fucking fraud.
Do you really think in 2023 it's impossible to make a horizontal line that's a half a mile long over water? Do you really, in your mind, believe that? Because they do.
Wait, say that again, Rakia?
Well, in 2023, they're saying it's impossible to create a horizontal line a half a mile long over static water.
I mean, I don't know. I honestly, at this point, I really don't care. I mean, I don't like. I just none of it is believable. It's all bullshit.
Not geometry, not straight lines, clear cut. Circles, triangles, straight lines, curved lines. Very clear cut and detailed.
It's only when you bring in light and the effects of light over distance that you can try and, mathematically change geometry. I don't know how else to say it. Like, not that you can do that, but in someone's mind, you do.
Yeah, they have variable radii, jagged edges. Anything's possible.
I mean, come on. The amount of fighting I had to do to just even get him to understand. I actually did make a mistake saying, but he's smart enough to understand, right?
Yeah, you corrected it, of course, right after, but that made no difference. We could all, that's not a thing.
Even when I was saying radius, he should have understood what I was talking about. He's drawing, he's saying the circumference line is not a circle or a sphere, and that it goes to the top of mountains and to the bottoms of valleys. That's craziness. And to say that's not a jagged line is weird.
Well, I think he did once clarified. I think he did say that it's jagged. Do I remember correctly?
Yeah, he did.
Shout out Kosho.
Well, he had to because he sounded ridiculous saying it wasn't.
Yeah.
So in the sphere model, their circumference line is jagged. It goes to the top of mountains, to the bottom of the valleys, I guess over the top of the oceans. But it totally obfuscated the point where the actual surface of their sphere model is below mountaintops and above water and below water and things like that. Like, it's not a perfect sphere. I guess gravity doesn't work as well on Earth. The force that makes things turn into perfect spheres, but then doesn't when it comes to the Earth.
A sphere, could it have a radius? The baller's got to put some deep thought in that one. If the Earth ain't a sphere, can it have a radius?
I'm not me.
Is that such a tough question?
I mean, are you asking somebody in particular?
What's your big brain question, I see?
Oh, big brain question, huh? Can if the Earth is not a circle, can it have a radius? Like if it's not a sphere, what you guys say,
Yeah,
can it have a
there you go.
radius?
Yeah, if it's not a sphere, it could be a circle and have a radius.
Yeah, if it's not you guys say it's a sphere, right? But not a perfect sphere, right? It's oval and this and that. And Rakia just went over how the radius extends from the water line if there's a mountain, so it would draw like a jagged circumference. So can a shape like that, can it have a radius?
Yes.
A non-perfect circle or sphere could have a radius?
Yeah, you would just need to specify more exactly what point the radius at what point.
Can you define a radius then?
Yes, but you would just have to specify the point at which you're asking what the radius is.
So not the center of a perfect sphere or circle. Some other random point which can change.
No, it would be from the center to the point that you're talking about.
Yeah, but isn't a radius supposed to be equal from the center to all around?
To the circumference, yeah, not to a point.
Yeah.
Why are you saying to a point? It's from a center of a circumference is a radius.
Because he was saying that you're taking into account the mountains and stuff, the topography. So if you're going to do that, then you need to specify those points. So those distances
That's not a
can be taken
radius.
into account.
That's not a radius then.
Yeah, that's my point.
What would it be if it's not a radius? What is it then?
Well, that's
Not
what
a
we're
radius.
asking you. We know what a radius is.
Still a radius.
Well, it's not a radius by definition. It might be a radius in your mind.
No, it's still radius by definition.
Okay, well then define it because you never have. He asked you to. I defined it.
I already did. It's from the center to whatever point on the surface you're talking about. If you want to talk
post
about the
it.
top of the mountain, if you want to talk about the top of the mountain, then that would be the second point. If you want to talk about the ocean, then that would be
Yeah,
the
we heard
second
you.
point.
We heard you. I said that might be a definition in your mind. Can you post that definition? Like, do you have a source for that? Is a source you?
No, I'm just telling you off the top of my head.
There you go. You're the source.
Is that 5 sigma?
What would you call it then? If you're saying I'm wrong, then what is it?
Ridiculous.
What am I wrong about?
I would call it ridiculous.
And is that 5 sigma verified?
So you're defining the line from the center to a point on the top of the mountain is defined as ridiculous.
No, I'm saying your definition is ridiculous. You asked me what I would call it. I said ridiculous. If you asked me what I would call a point from a center of a circle to an elevation change of that circle, I would call that elevation from the center. I don't know what you would call that. I don't even know if there's a definition for that. But to call it a radius is ridiculous.
It's still a point that makes a line from the center to a point on the surface. It's still a radius.
Well, if you draw the circle from the top of the mountain all the way around where everything else is below it, if the top of the mountain is the tallest thing, then you could call that one line a radius to that circle, yeah.
Yeah, exactly.
So that's what you're doing?
Sure.
The circumference from the top of the mountain, that radius to the center of the circle is the radius of that circumference.
Yes.
To that one point.
Yes.
Is that in any geometry class? Can you cite that anywhere? Or are you just thinking, like I said, have you read that somewhere or are you just thinking of it?
It's just what is a radius? It's of the two
That's not what I
points
asked. You want me to repeat the question?
From the center to the surface. Just because you're changing the distance on the surface doesn't make it not a radius anymore.
Okay, I'll ask again. Can you cite it when it has to do with Earth or geometry or whatever, or are you just thinking that in your model?
If you're that interested, you can look it up. I'm walking right now, so I'm not going to go look in geometry books for something this simple.
So you're saying it's in there?
Yes, I'm sure you can find something on the internet or in a textbook about if you have, polygons and things like that where the distance changes, you can still have a point from the center to different points on the surface of those shapes. You just have to define the second point specifically rather than generally, and it's still radius.
This might be a
by
bad time.
definition, it's not a radius.
Well, let's start off with the definition of a radius.
Then, SC?
Yeah,
What is it?
calm down, sir. Just keep walking. Be
Oh, I'm
careful. Don't
fine.
trip on anything. I'm going to give you the definition of a radius. We'll start here. I'm
Sure.
not walking, so I can post one. A straight line
Please
from
do.
the. Yeah. You ready? You done talking? You ready?
Yeah, go ahead. I'm waiting on you, man.
Yeah, you're ready, right? You don't have to say another word. I can go ahead right now.
Go ahead.
You do have to say something else. You done? Okay. A straight line from the center to the circumference of a circle or sphere. I agree with that definition.
Yeah, but is that the only definition? Like, what about, there's some definitions like S equals theta times the radius. You could rearrange that to get the radius is defined as S over theta. That's another definition of a radius.
Here's another one. A radius is a measure of distance from the center of a circular object to its outermost edge or boundary. That would match you pretty good.
Yeah, that works.
I'm pretty sure it's equal all the way around the circumference, though. I think that's one of the must-be's, right? Yeah, that was a rhetorical question. Yeah, that's a fact.
Is it though? Because you can easily change S or theta.
You can change anything you want, but in reality,
Well, that
a straight line
nullifies
from the
what you
center of the
said.
circle is even all around the circumference. Everybody knows that.
Then you wouldn't be able to change S or theta.
Can't change nothing in a circle. It's defined. The radius, the circumference, the diameter, these are all defined. You can't change them, bro. Sorry.
Yeah, but you're asserting that that's the only definition of a radius. I don't think that's true.
Well, okay, then we're asking you show us another definition. I mean, I never heard another definition.
I just gave you one, right? You can use the S equals theta times R, right? You rearrange that so R equals S over theta. That's another definition of a radius.
That makes absolutely no sense.
Oh,
I have a
S
feeling
is
you're going to
the
need
Are you
arc
talking about a
length.
variant?
S is
Sorry.
an arc length. Theta is the angle from the center point of the shape.
Right, but does the radius value change in that
Yeah.
formula?
It
And it's
would,
not.
yes.
Then it's not by definition. It's not, bro.
Oh,
This is some
sorry,
sort of
man.
other geometry you're talking about.
No, this is just basic Euclidean geometry. It's, like trigonometry and pre-calc is where I learned that definition.
I don't know what to tell you, my friend, but a circle is defined, a circumference is defined, diameter, radius, these are all defined.
So I would Google something like, can a octagon have a radius? Right? See what that says. Because an octagon has the distance around the circumference is constantly changing.
Okay, then, are you claiming that the radius of the Earth, which you believe in, changes?
Yeah, if you're going to take into account mountains and stuff, if you're defining the radius as the point from the center to some specific distance, like the top of a mountain or the middle of a mountain, then yes, you would have different radius values, right? The radius, if you're going to use the top of a mountain, is going to be different than the sea level, the radius to the surface of the ocean. Those are going to be different distances. That's why they have like the oblique spheroid and the geoid models and stuff, because it's not just a perfect sphere. I think a lot of the times the number that's quoted, the 39, 59, whatever, I think that's just like an average or maybe a sea level radius average. Oh yeah, see, right here on Google. The radius of a regular polygon is the distance from the center to any vertex.
Sorry, bro, I had to step away. So how about, so did I ask you if then your circumference is variable on Earth? Did I get that question out?
Yeah, sure.
And what's the answer?
Yeah.
So the Earth's radius is variable.
Yes. Why is this in contention? That's why we have things like the WGS, the geoid, the oblate spheroid, all these different models, because there's topology, topography, there's things that change the shape and the distances.
So how do you arrive with your exact number then? How did
I said that before. I don't think it's an exact number. I would think that the 3959 number that's often quoted is probably an average or like a sea level average. That would be my guess.
So an average. Okay, interesting.
Yeah.
So we got variable radii. Nice. On Earth. Yeah, that's
that would make sense. I mean, the measuring an average of the rising, because how the fuck do you measure it otherwise? As Oakley always says, is it no Atmo day? You know what I mean? How the fuck do you measure it?
Also, the first result on Google is the radius of a regular polygon is the distance from its center to any vertex.
okay. So they've come up with well, I've heard that before, to be honest with you, but it's kind of weird, especially when you start off with the point, the line, the circle, and then you're going into then you know that you define the radius as being equal from the center to any point all around, and then you hear like variable stuff. I mean, I don't know. I guess everybody could make up their own mind on this one.
Yeah, well, I don't know. Globers shouldn't have contention with the Earth not being a perfect sphere, and thus the radius is not the same everywhere.
So then the 1 degree every 69 miles, where is that from, in your opinion?
I'm much of a celestial navigation guy, but I believe that comes from measuring how far a star moves as you move on the Earth. Isn't that where that comes from?
As you, sorry, I was like partially listening. Can you repeat that, please?
Yeah, I'm not much of a celestial navigation guy, but from what I understand, that comes from like how far a star moves, how many degrees it moves based on how much you move on the surface of the Earth.
Right. Yeah. Every 69 miles. Yeah. And from that, I guess, because they claim from that they somehow came up with circumference, although be it a very jagged one, as we've come to find out. See, it's kind of fantastical, man.
You would come up with you come up if you just did one measurement like that, right? You could come up with the circumference and then model that out with the topography and topology of the land and correct your circumference based on that.
You want to hear my latest joke, Jace?
Go for it.
All right. How do you get a glober to concede a point?
How?
You draw a straight line between two of them without a change in elevation.
Nice.
That's some good straight line jokes. Nice.
Have you seen Veritasium's new video, Essie, about the Euclid's fifth postulate?
Oh yeah, about a couple of weeks ago. Yeah, when it first came out, I saw it. Yeah, pretty interesting.
Yeah, it is. It is.
But nothing new that I haven't heard.
Yeah.
They took away
thing with the supernova, I was unaware of that.
the supernova. Which one? Oh, the one that went dark. Is that what you're saying?
No, the
no,
one
no,
he
that's
talks
Beetlejuice.
about.
That's Beetlejuice.
The one he
Sorry,
talks
Ron.
about. The one he talks about in his video, how they saw it in 4 different locations. Then they did the modeling for a galaxy that would be in between us in a different location, and like a year later, they observed it basically right when they predicted that light would make it to us.
No, I haven't heard that one.
Yeah, it's interesting. Kosho said, because I brought it up to him, he said he's brought it up before, but I had never heard at least the details of it.
Yeah, it's this. They better get that right, because after the standard candle, that's what they're measuring now, right? Like quasars.
Oh no, this was a lensing thing. So they saw the supernova at the same time, or like the same day, in 4 different locations. But then they knew that there was a different galaxy along a different path that would make the light, if it was being lensed, as Einstein predicts, it would make the light take about a year to get to us. And so they did the modeling to find out exactly, based off of general relativity, what day and time the light would get to us. And then, they did the observation, and sure enough, the light came right when they thought it would.
Okay. Well, I'm glad they're getting some stuff right.
Oh yeah,
Because they're having a bad time out there lately.
Oh no. I posted the review, and then saying that Einstein's like the most accurate to date cosmological theory or whatever. The quote's in the chat. I posted it yesterday from the review article along with the link.
Well, maybe he's the most accurate, but it's going to have to be all redone. His stuff is going to be laughed at maybe in 10, 20 years from now. I'm almost certain of it. Maybe not even that long.
Likely.
But it would be much quicker. It would be a couple of months if that was really true, right? We don't play pretend. We would update the models. If someone disproved some major aspect of like proteins or nucleic acids, we would be searching for new models, for the more accurate models, almost immediately.
Well, yes, but you would also continue to use the established models in the scope that they're still present, that they have been working in, like Newtonian physics, classical mechanics. It's been disproven by special relativity, but we still use it because it's still a very good approximation for speeds that are low compared to light.
Yeah, because right, it's not really disproven. It's special relativity showed the limit at which Newtonian physics is valid. It showed where special relativity breaks down or just turns into the same thing as Newtonian physics.
Well, yeah, but ultimately, if you're being strict, then special relativity disproved the laws of motion. They don't hold true. Like motion doesn't stay linear. Mass doesn't, like the impulse doesn't stay unaffected by the speed. The mass doesn't stay unaffected by the speed. You have a relativistic increase of mass, apparently. So
He's
the
right.
laws of motion don't
He's
hold
right.
true.
They're not the same. Yeah.
Yeah, I mean, it's fine what he's saying, but just as long as you know that it's not really disproven, it just showed the limit, right? It showed where the equations, the models of special relativity, what conditions they turn into the exact same thing as Newtonian physics. And it just showed that it's not every situation that they're the same thing. There is a distinction between the situations where Newtonian physics and special relativity are the same thing, and that special relativity is a different thing. It showed that distinction.
They're not turning into the same thing. It's just that when you have lower speeds, then the relativistic effects become negligible. They become so small that our variance of how accurately we can measure things and how accurately we can determine the start position of things become much bigger than the influence relativistic effects have. But that doesn't mean that the special relativity turns into the same thing as Newtonian classical mechanics. It's just like the difference becomes not relevant. But in the same way, I doubt like if things continue that way and if like there's no huge revelation of deception, then Einstein's other work with general relativity will never be laughed at, just like Newtonian physics and classical mechanics is not laughed at, even though we know that it does not hold true exactly.
Well, I get what you're saying, and I agree for the most part. When I say the same thing, I mean the equations, the special relativity equations, simplify into the Newtonian equations within a limit, just like in general relativity. Right? If you have baryonic matter that's not moving a significant fraction the speed of light and the gravitational field is not changing over time, Einstein's field equations and those potentials simplify. The extra terms become zero, and the equations just they take the form of Newton's equations, but just with a correction factor, and that factor is usually zero if you're not considering dark matter or dark energy. So they become the same thing mathematically.
No, exactly not. They don't become the same thing. It's just that the difference becomes negligible. There's
They
still
do, though.
the
I've
fact.
posted the derivation going step by step how they become the same thing. You start with Einstein's field equations, or you can start with the geodesic equation. In both situations, right, with those three conditions, that you have baryonic matter, it's not moving a significant fraction the speed of light, and the gravitational field isn't changing over time, you'll end up with the same equations as Newtonian physics, just with a correctional factor, and that factor usually also becomes zero if you don't need to consider dark matter or dark energy.
Oh, you're talking about general relativity. Okay, that could be.
Yeah. But I mean, the same kind of thing happens a lot with special relativity too. But I get what you're saying, man. I get what you're saying.
So you guys came to an agreement?
Yeah.
So Newtonian, mass attracting mass, actual stuff. That's one thing. The other thing is take time and space, put them together, make a fabric. When a mass goes near it, it warps that, and that's gravity. And somehow, mathematically, you want to convince people that that is the same thing using math.
Well, it's not convincing people. It just is. The equations simplify into the same thing under specific conditions like those present here on Earth. But if you want to draw the distinction between the mechanisms, so you're still left with the same result. Whether you think there's a instantaneous force like Newton proposes that draws two masses together, or you think the larger mass bends the space-time, it's such that a smaller mass will be drawn towards it. It both results in the two masses drawing towards each other.
Yeah, of course they have to. Obviously, they're trying to explain the same thing. I don't see how that in any way makes one better than the other.
Well, even Newton was iffy about the whole instantaneous force thing.
Yeah.
He just, they didn't have the knowledge and the mathematics back in his time to correct that proposal.
Yeah, but how does one convince intelligent people that there's such a thing called the fabric of space-time? Like, that boggles my imagination. To me, it's like believing in a unicorn. I'll be frank with you. How can an intelligent, educated person believe that?
Well, I think you have to be very specific. Like, if you think that intelligent people, as you're saying, think that there's something like a cloth, like analogous to a cloth that is the fabric of space-time, they don't think that.
But they show that every time they explain it, correct? They have a
Yeah, they're
trampoline with a
simplifying it.
ball, simplifying it. Okay.
Yeah,
So how would you like?
in an actual graduate level physics class, they don't show you a trampoline with a cloth and a ball and marbles going around and none of that stuff. They show you the actual equations and how to come to predictions and stuff like that that's actually useful.
So equations, no visual representation.
Yeah,
In,
they teach you
in
how to
uni.
set up. They teach you how to set up coordinates. They may give you a visual representation. I was given some just so you can have that understanding. But they make sure, at least my professor made sure to specify that we don't think there's an actual trampoline that the marbles with a ball in the middle that the marbles are going around. This is just an analogy to kind of grasp the concept of what's happening. But the coordinates and how you set up the problem and the tensor formulations and covariance and all that is really what you need to focus on.
Well, how would you explain it without using math?
That's
In
a
the
good
uni
question.
level. Sorry?
I said that's a good question. I mean, I guess it would just depend on the class, right? The trampoline thing with the fabric and the marbles going around, it's fine for undergrads, for people who aren't science majors or never going to need to use general relativity to solve any problems. So that would be fine for them. But if you're teaching graduate level physics class or a graduate level science class that's going to need that, then you have to teach them the math, because that's where the actual understanding of coordinate systems and covariance and contravariance and all that comes into play.
So really, there's no real way to explain it to a normal person without using math.
No,
Or
you're
visual.
stuck with the trampoline kind of analogies or the
I'm not
math,
stuck. You're
basically.
stuck. You're stuck, bro. Me, notice what I said. I said, how could somebody believe in such crazy stuff? I believe I said, or something like that. How could an
It doesn't need
intelligent
any.
person? So you're telling me now by saying covariance and this and that, you think that actually means anything, or that?
Oh yeah, they have deep meanings in mathematics. Allow you to do very precise and accurate predictive modeling.
But you find it difficult though to explain it in words, right? I mean, if I had a gadget in my head, if I had a model in my head, I would be able to explain it, this, and that. But you're saying the only way that this could be explained is through mathematics or expressed. The only way it could be expressed is through mathematics. You can't give us a rundown in the uni level of what the fabric of space-time is. It's that difficult.
No, you brought up the way that it's typically explained with the whole trampoline ball on the trampoline with the marbles going around. That's probably the best way to visualize it, right? But if you want the actual useful understanding where you can actually do predictions and whatnot, you have to get into the math.
Okay, so it is like a depression in a fabric, and when another object comes close to that object causing that depression, it starts swirling around. That's basically it then. So there is no other explanation in uni, only the mathematics to calculate. Is that what you're saying?
Oh no, because I've given different explanations other than the fabric analogy. But you could just think of it as a coordinate system, where if you just have, a blank coordinate system with no masses present, you have the X, Y, Z axes, right? The tick marks, the 1 distance, 2 distance, 3 distance, they follow in a straight line. But if you
A
have a
grid system.
mass there, if you
A
have a
grid system?
mass, there, then those paths, the distance markers, are not in just a straight line; they're curved.
So a curved grid system.
Yeah, that's another way I've explained it. I've seen it explained at uni before now, because you can kind of represent something that's similar to 4-dimensional with that, though it's not exactly 4-dimensional, but it gets the point across.
So basically, it's like you took 3D Euclidean space. You took the grid system and you curved it, and somehow that's supposed to explain the fabric. Right again. Your mind is going to, like, the grid is like a fabric, right? Is that how you're thinking of it?
Well, no, that's more true to the mathematics, right? You're making coordinate systems and seeing how distances measure up in those coordinate systems and whatnot.
So a coordinate system, that doesn't explain gravity, bro.
Of course it does.
A coordinate system explains gravity. Okay.
Yeah, when you plot out what the coordinates look like when you have a large mass and then a second mass that's smaller, right? It'll show you exactly what happens as long as you formulate it properly.
This is news to me. A coordinate system is
Sure it
gravity. I
is.
mean, that's the first time I heard that one.
Oh, that's just a silly straw man. That's not what I'm saying.
Well, then, my apologies. Correct me. You said a grid system that folds, that curves. That's the fabric of space-time. That's gravity. Did you not say that?
No, I didn't say anything about a fabric in this case. I just said you have a grid system, right? A coordinate system, a graph, basically. And you have a mass, large mass, and you have a second smaller mass, and you want to calculate what the path will be. So you're predicting what you're going to observe, right? And you'll see when you formulate it in the general relativity way, you'll see that the smaller mass will be curved into the larger mass, and we call this overall process gravity.
Wow, that was pretty interesting there. So what's the mechanism then? If that's just a graph, a plotting system, what's the mechanism that's making the other body go around? Surely it can't be the graph, right?
No, it's the mass. The larger mass is changing the geometry from just the flat Minkowski metric to a curved metric.
So trampoline. Back to trampoline.
That's an analogy, sure.
Okay, so you believe that object bends space and time. Correct?
Yeah, it changes the geometry of the coordinates. Sure.
Yeah, I mean, yeah, okay. So we're back to trampoline. So you tried to explain it by a coordinate system, but then you ended up having to bend that coordinate system and making it a fabric again. I mean,
I
there's
said
no way out
nothing
of
about a
this
fabric,
model.
or I've said nothing about a fabric or
So what
trampoline
bends?
in that
The space.
case. The larger mass changes the coordinate system, so it's no longer just the flat Minkowski or Euclidean geometry in 3 dimensions, changes it into a different geometry, usually the Schwarzschild, but there's other ones like the Kerr, the Cartan, etc., such that another mass, a smaller mass, would have its path bent towards the larger mass.
So you're curving space, you're bending space, right?
Yeah, the distance markers on the coordinates are changing, yes.
Because the fabric is bending, the space is bending, right?
Well, that would be an analogy. And the case I'm talking about, the space is just those coordinate markers.
How is that? Does that make any sense to anybody?
That makes perfect sense when you actually do the work.
Look, you're just saying
It's
things. You're just saying that.
incredibly predictive.
I don't know. To me, it's like you're going around in circles. It's either space and time make a fabric, and when an object an object of mass comes close to this said fabric, it bends it. That's your model. And then another object comes, right, and falls into that well. That's your model. Oh, now, I don't know. To me, it's like you're going around in circles. You say yes, but that's not the universe description. And when I ask you, okay, how about the universe? What's the uni description? You tell me a coordinate system. Now, I don't know, bro. If you if you think that's sufficient, what can I say? How could a coordinate system be gravity?
Because it's not. That's not what I'm saying. It's not what I've said. You're just refusing to listen. You're stuck on this analogy of some kind of fabric. Space doesn't have to be a fabric, bro. That's just a way to explain it to people so they can visualize it. But in reality, there's no requirement that space is some sort of fabric.
Okay, and I'm asking you, tell us how. What's the
I have
mechanism?
been.
You said coordinate system.
Yes.
Okay, then we're at
A
conversation over. I mean,
large mass, if you have a coordinate system with no mass, you'll have just a Minkowski space in 4 dimensions or a Euclidean space in 3. In those spaces, say you have the X, Y, and Z axes, right? The distance markers where you have like 1 centimeter, 2 centimeter, 3 centimeter along those axes are just straight lines. But if you have a mass, what causes gravity, what is gravity that we see? What we call gravity is when there's a mass present and it changes the geometry of that coordinate system so that they're no longer in straight lines. And the result of that is if you have a smaller mass coming into proximity of the larger mass, its path will be bent towards the larger mass.
is it bending the space?
It's bending the distance markers, the grid.
How?
By coupling to it. There's a constant for, per unit of mass, how much it'll bend based on the geometry.
So it does bend. Space does bend. You
The
see what I mean?
coordinate
You know what?
system will bend, yes.
Let's disengage, bro, because you're frustrating me. I mean, We did good so far. Let's keep it that way. You're going around in circles and a bit of double speaking, bro. I'm sorry. It's frustrating.
No, I'm not. You're just grandstanding now. You just have to actually do the work, have any ambition to try to understand it. It's really not that difficult.
Well, it seems it is difficult to you because you can't explain it in a manner without referring back to the trampoline. And when I tell you that, you get triggered. Does the
I
space
haven't
bend?
referred back to the trampoline once. You're the one who keeps doing that.
You just said that space bends.
Yeah,
Did you
that's
not?
not a trampoline. The coordinates bend.
The coordinates. You mean the XYZ bends? The numbers bend? What bends?
Yeah, the coordinates, the numbers, the location in space of the objects and the path they will take.
So the space bends then.
Sure. That's not a trampoline, though.
Okay, maybe it's not a trampoline, but you're bending space. You're bending space time. You're bending something. You're making air bend.
Oh, no. We're not talking about
Yeah,
air. We're
that's
talking about the coordinates, not air. Air is a material object made of matter. We're talking about the coordinates, the XYZ grid system, and T in some cases.
oh T. So now we're getting there. You finally said it. So you're adding T. There you go. So that's your fabric.
Yeah, I have added T the whole time. Minkowski space is just Euclidean space with a time coordinate.
Right. That's very interesting. So just take regular space and put a T there. Got it. Yeah, I'm glad. I hope everyone's listening. This is their model. They take time,
I
they take
do.
space, they put it together, they make a fabric, but then they say it's not a fabric. But you have to think of it. It behaves like a fabric. Yeah.
Yeah, if you want to try to visualize it, but there's no need to do that to do any kind of predicting, observing. Any of the mathematics doesn't require any of that. You do it all with just the math. You don't need to have any kind of visual understanding.
Hey, I just want to cut in, Essie. That was that was awesome, bro. Good job.
Well, you got
Did
a
you
fan.
understand like what he was trying to say? Like, did you?
You got a
Was the
cheerleader,
explanation?
bro.
No, I'm just. It doesn't matter.
We're
You
all
know, this
kind of chuckling
channel,
actually.
obviously, we're gonna get more than you. So I don't. I'm not getting a big head. I'm just curious if he understood what you said, Jace. If it was satisfactory.
Honest people shouldn't be coming to me for their understanding of general relativity and this stuff. They should be trying to work out the math and work out the different ideas people have put forward themselves to try to understand it. Right? I'm just giving you a few ways I've heard for ways to visualize it, right? But in reality, it's the math that you actually have to do to really understand it.
Is it possible that it only exists in maths?
It is.
It
It's a
could
fact.
be,
Not only
right?
possible.
The thing that shoots that proposition in the foot is that this math has extreme predictive capability. We can predict things beforehand, make observations, see exactly what we predicted. That leaves you with either we have to be at least somewhat on the right track or it's somehow a coincidence, which is extremely unlikely that hundreds of observations have been predicted by general relativity and we're all just coincidental somehow. That would be ridiculous.
What would be a thing that you predict?
I gave you one earlier about the supernova thing. Right, they saw the supernova in like 4 different locations because of the lensing, but then they knew that there's another galaxy that would be along a different path for the light that the light would be taking, and it would take longer for that light to get to the Earth because it has to go around this other galaxy and it's being bent and whatnot. And so they made a prediction for when we should see that light from the supernova. And it was about a year later. And sure enough, they looked, where they needed to look in the sky for the supernova, and they saw it a year later. The same thing happened in the sky again. That happened a year before, right when they predicted it would.
Yeah, I think for, I mean, I'm kind of simple, and and I think for a lot of folks who haven't looked into it, as you say, we hear you saying things like space time, and I know what those words mean. You know, time is a concept, isn't it? Right? Convention. Space is
No, it's
length,
a
breadth, and
coordinate.
depth. No, but dude, the point is you cannot bend them. That's where we struggle a little bit. You see?
Yeah, I get that. That's your assertion, right? And
What?
yes, we can't show you, like, I can't grab a piece of space-time and like bend it in front of you. That's not what anyone is saying. But what they are saying is that this model of space-time allows us to make these crazy predictions that we can then observe. So we have to be at least on the right track, unless you want to postulate that it's all just a coincidence, which would be highly unlikely.
Yeah, I mean, could I like make these observations?
Some of them.
Hmm.
Well, I mean, you can make all of them if you were willing to go to university and get a PhD in astrophysics. Then you can make any observation you want. But if you want to just stay, a regular person, there's only the backyard astronomy that you can do, and whatever kind of relativistic observations you can make doing that.
Right.
I posted something. Is that kind of like the coordinate system that you were talking about? Bent? That would have to be your visual, right?
Hang on, I'm looking for what you posted. No, that's just another version of the trampoline thing.
I thought you'd like the coordinate system. I made this like a couple of years ago. How would you visualize it then, bro? Or you said you had they showed you some visuals in uni, I think you said. You think you can
Yeah.
post one? Like, I'm curious, like, how do they envision this?
Yeah, maybe later I'll post some of the things that I've seen before. But like I said, the trampoline thing is one of them. It's one of the ways they'll show you. Another is just making like what looks more like a four-dimensional coordinate system. Obviously, we can't see in 4 dimensions, so it's not really a four-dimensional coordinate system. But there's ways to make it look all trippy and like it's 4D, and to make a grid system out of that.
I don't know. I can't possibly imagine how you're visualizing this, bro. Like a grid system that's not a grid system, that's like a trampoline, but not a trampoline. Like if you were to do a visual, it would help greatly. I want to see how university people think of this because they're way smarter than us, no? Yeah.
I'll look for one later for you when I get back.
I would appreciate it.
Yeah. But the thing is, though, right? Like reality isn't dependent on what we can visualize and represent visually, things like that. There's tons of stuff that we can't see that certainly exists.
I have no doubt of that. Can you see magnetism?
Yeah, exactly.
Yeah. But this fabric should have some model, some design. It has to have like a visual, something that could be explained non-mathematically. Otherwise, it's just a formula.
That's the thing, though. It is a math thing. Gravity is a math thing. That's the whole point. All these other visualizations are simplifications of the math put in a form that we can visualize.
Right. So
And by the
you're
way,
admitting that
electromagnetism is also just a math thing in the same way.
no way, bro. What are you talking about? You can experiment it, you can show it, you can make it, you
Yeah,
can
same
reverse
things you could do with gravity.
it one way, you can make light the other way. That's not the same, bro.
You can do the same things that you can do with gravity. You can't see electromagnetism the same way you can't see gravity, but you can see its effect on objects.
Can you manipulate gravity?
Sure.
You can manipulate gravity.
Yeah.
Are you okay? Are you feeling okay? Bro, seriously.
Tell me what's wrong with that. I don't get it.
How how are you going to manipulate gravity? First of all, which one are you manipulating?
It doesn't matter which way you want to put it.
Okay, how are you going to manipulate it? Please explain.
It's gravity, no matter what way you put it. It's two masses attracting towards each other. Whether you want to go the complex route of coordinate systems having different geometries, or if you just want to keep it at a force, doesn't really matter. But a way that's demonstrated is the Cavendish experiment. That's one of them. There's also these gravitational lensing observations. There's the Einstein cross. There's redshift of the CMB. What's the name of the effect? I forget what the name is, but it's where the CMB will have different energies as it goes past the galaxy when it's on the far side versus the near side to us. Like, there's tons of ways to see these gravitational effects and gravity being manipulated.
That wasn't the question. I said, can you manipulate gravity? Like, I can manipulate electromagnetism. Make a magnet the other way around, light a light bulb. You can't do
Well,
that
that's
with
not
gravity.
you manipulating. You're just turning a magnet. You're not doing anything special.
Yeah, but you actually have some product in your hand. You have the mechanism. You have the brass. You have the magnet. You have the light. You have the wires. What do you mean? You're definitely manipulating something.
See, you're not a magic man, dude. You're just turning the magnet or changing the current. You're not physically grabbing the electromagnetism and manipulating it in any way.
Is that what I said? Did I say I'm Merlin? No. I
Also,
said
it
this.
appears you're.
You know you can manipulate gravity, bro. The same way we can do, with electromagnetism. So
I
I don't know
I
what
see. It's going in your file. You're not a magic man, apparently. So.
Yeah, exactly. In analogous ways, you can observe these CMB effects in different directions, right? So you're changing the directions the same way as rotating a magnet does. You can do Cavendish different ways, change the direction that the masses attract or how they attract. There's all sorts of different things you can do.
it looks like I really, really triggered somebody, and it's very rude of you, Starcotter.
Oh, I gotta go. I see. So
All right, bro. Nice talk. Is that how your mom taught you to speak, Starcotter? I'm sure if she was here, she'd wash your mouth with soap. That's what they used to do, no, in the early days? Wash your mouth with soap, young man.
I was just thinking I need to get back into. I don't know. I was thinking about. Sorry, that was a good conversation. I see. I mean, not that we haven't heard it a million times before. Sorry. I didn't want to change the topic if you wanted to carry on with that, but I was just thinking about how people are making bank on YouTube. I need to. I was looking at what were trending, and it's like the usual: foosball, video games, fighting. Matthew Perry's died. Lots of people arguing, pissing and moaning. Lots of egoic things. I don't think I could lean back into the ego, not after pretty much destroying it. So I don't know. I don't know what to do. But I'll tell you something. What wouldn't be trending? Truth or shit. I was just giggling to myself. You're right. I was looking at it, thinking, I need to get away from this truth or shit. I didn't even know Harry Kane plays for Bayern Munich now. He plays for a German team, perhaps the biggest German team, and he's England's captain. I mean, bloody hell. I used to follow all this stuff years ago. So it's like I looked into pop culture for about 15 years. I don't think I miss it. It's always a controversy as well, isn't it? Always people love a controversy. You know, I was watching that A Rich Man's Trick earlier, which is one of the first truther things I ever watched. And Clay posted it in the chat, and I thought, oh, I'll watch a bit of this. And man, there's so much grabble in it. I didn't even realize. There's a lot of pushing false narratives in that, and I had no idea. Of course, the first time I watched it was probably 2000, maybe when it first came out. I don't even know. No, wait. It's got to be 2000 because it's called JFK to 9/11, so it must be 2002 or something like that. JFK to 9/11. I'm pretty sure that's the subtitle of it. So yeah, 20 years ago. And I watched it for an hour, well, roughly an hour, and I thought, God, I don't agree with a lot of what's being said here. I think I might end up going up to that politics server then if nobody's coming in here. Might come back later. Have a listen to them spurging out about. I bet they're talking about gas pressure again.
What politics server?
It's 24/7.
Yes.
They used to be hosted by this politics server, which has quite a lot of traffic going through it. and they've hosted them again. So they've got like a little room in the. Well, I say little. There's about 40 people in there now. So.
Oh, okay.
Do you want me to send you an invite, Clay?
Yeah, you can send me an invite.
You're not that keen on 24/7, though, are you? That's the thing.
Oh man, I worked with someone at work on weekend, and she came to work sick, you know, like coughing and stuff, and now, you know, 2 days later, who would have thought I get a cold? So nice. I love it. Dude, why can people not just stay at home if they know that they're sick?
Yeah, the less I talk about that, the better, probably. I don't think that's how it works. But
Oh, I know why. You mean like, you know, because you don't get sick that way, right? Okay, I see the server. And I should join the 24/7 Flat Earth channel. Hello?
I get it. They're all simping for fight the tight shirt. That's where they're all at. Go make 'em money. Unbelievable.
Okay, the lines are not the same, bro. Can't say that they would be.
Say what?
Sorry, I've got AK there. I'm Sorry, I heard no one else talking or saying anything. Was anyone else saying anything? Or was it just silence? Yeah, sorry, I'm having a message thing with AK on one of Wolfie's observations, which I sent him. But I can't keep messaging on messages as I have other things to do. So I just jumped here and I saw that he was on. So I thought, oh well, I'll just jump on here and you can talk about it. But yeah, the lines don't match now, AK. When you drop down to the lower levels, you can see that the lighthouse is going to be obstructed by a few meters now.
Can you substantiate that? Because the view that I showed first matches up pretty closely. Then you corrected me by the first time you corrected me by misidentifying a tall tree in the first place that you later conceded was not visible in that shot in the first place, right?
Yeah,
And even with that
from a
line that
different
you
angle.
drew in, the mirror line would be very close to the base of the tower. And now you're
Close to.
baselessly claiming like, yeah, now the lines don't match up. Like
No.
you
I never said
constantly
that.
move the goalpost.
No. I never
Like
said that it was right at
you
the base of the
constantly
tower.
say the predictions don't match the observation, but you never substantiate the prediction in any valid way.
Prediction is not matching the observation. The prediction is
No,
what they
you're
were.
not making a valid prediction in the first place. Again, when it's 70 degree Fahrenheit, when it's 20 degrees centigrade outside, right? You're claiming that the weather report predicts snow. And then somebody explains to you that the weather report does not actually predict snow. They just explained to you. They just had a small section about clouds and how when the participation starts, they start out as snow, but it's getting too warm, so it comes down as rain. They're not predicting snow when it's 20 degrees Celsius outside.
Okay, now let him respond.
Rain.
Okay, AK, you've clipped him every time he's spoken. So okay, let him respond. Keep yourself on mute until he's finished. So go ahead, Plain.
Sorry, I dropped off because there's a phone call coming through, so I'm just waiting for it to hang up. Sorry, you still there, eh? Okay.
Yeah.
Oops, sorry, yeah, I couldn't hear anything that was going on then because a phone call started coming through. Yes, I admitted that when we were looking at that tree was on the wrong angle, so we corrected that. That's fine. But then it's still not matching. There's still, if you were to be drawing lines across, then you're still going to get a few meters of the lighthouse missing. You can't go using temperature data from, almost 10 meters above the height of the actual observation
And you're
point.
not using any data. You're not using any data. You're just assuming it's standard reflection or no reflection at all, which is obviously not true. There's an inferior mirage. So the prediction that you're using is obviously false. It's not the correct prediction. And then you're comparing a prediction that is not expected to occur to an observation and say like, well, the prediction doesn't match the observation. It's like, well, the weather report doesn't predict snow when it's 20 degrees C outside.
Okay, for starters, hold on a fucking second. Wait.
And you keep babbling on about a weather report that predicts snow.
AK, stop for a moment. AK, stop for a moment.
Yeah, you have to stop interrupting, man. It has to go back and forth.
Yes.
You're clipping and you're yeah, please don't do that. Go ahead, Plain.
Okay, so AK, show me where Wolfie in that video says what you're saying. Show me where Wolfie went in and Wolfie. Right, exactly. So then don't sit there and expect it from me. No, I'm not moving the goalpost. What I'm doing is demonstrating. What I'm doing is demonstrating.
You're moving goalposts from this
Stop
conversation. You're going back to Wolfie. We had this sorted already.
Interrupting AK.
We had this sorted already. You're moving the goalpost back again.
No. Stop interrupting AK. Okay, you need to show where Wolfie said all these things that you're now saying. Did he include any of what you're saying? It's a direct question. Did he include anything of what you're saying?
Yeah, I can't respond to you when I'm muted. Modding is kind of slow. Well, he did not. Question
He
for
did
me.
not, did he?
When was in our conversation just now, since Plain Reality came on, when was Wolfie mentioned?
Well, we're talking about Wolfie's video, so it's completely relevant.
We had that sorted already, Plain Reality.
No, we
If you
did not
made a
have that sorted
mistake,
at all. That was never even
yes,
discussed.
yes, we had that sorted already. You can go back through our text messages. I can quote it to you if you want. Should I link you the messages? I had it sorted.
Messages where we discussed Wolfie didn't use these predictions?
Yes, we had that sorted out already. In reality,
Yeah, you can link it because I don't
we
remember
were in
seeing it.
agreement on that. And go back through the messages, or do you want me to link it to you?
You can link it because I don't remember mentioning that Wolfie didn't include them. I mean, possibly we did.
We went on many times about that. You're not very good at following. No, you know what? I'm not gonna link it to you. You can scroll through it yourself.
Many times.
I'm not gonna do all the work for you. I already
Yeah,
dumped a day of work into this, so no.
that's because we didn't.
I retract what I said.
We didn't mention Wolfie and him not
Shit.
predicting the temperature variations.
Bullshit. Well, we talked about, and we didn't talk about him predicting temperature variations. Yeah, we did. We talked about how he did not include them or not talk about them. That was topic multiple times. You can scroll back up.
I
You
think I
seem
do
to
remember.
miss a lot of questions that I'm asking you.
I think
You're
when
very
you
bad at following
mentioned it,
especially considering you have a
I'm trying to
backlog.
answer
You
you,
literally
AK.
can read up.
I'm trying to answer you, AK. You need to learn
What are
when
you
to
trying
shut
to answer?
up. I am saying
What are you
I
answering?
actually. See, you just keep fucking going. Oh my god, dude. I'm trying to say to you, okay, I do have a recollection of mentioning something to do with the temperature and him not mentioning it. Okay, I'm trying to say that. You don't give me a chance to fucking talk. Come on, bro. Right. Now, when he hasn't included that information, he can't then make the claims that he's making either, can he? He's claiming the entire lighthouse is visible. The entire lighthouse is not visible.
You're wrong on that.
I'm not wrong on that,
Almost
AK.
exactly the entire lighthouse is visible. You keep
No,
asserting it's not, but you never
no.
substantiate it sufficiently.
There is a few
You never
meters difference.
substantiate it sufficiently.
I have
Just go
substantiated that.
nah. Just go nah. Now that's not the view. Except the features of the land that we're seeing above the mirror line matches exactly.
Yeah, it matches a
go.
few meters above.
Therefore, it doesn't.
It matches a
Fucking
few
God.
meters above.
Yes, the mirror
Wolfie's
above the mirror
prediction.
line. Yes, that's the
Okay,
only thing we have.
okay, so now let's go into what was Wolfie's prediction. What did Wolfie use? What numbers did Wolfie use?
Oh my fucking
Do you
God. We
remember?
went through that already. We had
Do you
it
remember
sorted
what
out. I'm
numbers?
not going to go through it. If you're just going to waste my time, I'm not going to go through it with you again. You can scroll
Okay,
up
so
for our
let's.
chat. We had it sorted out. Move on.
No, I'm doing it for the people in the audience.
Scroll up through the chat.
Okay.
You can repeat it on your
So
own time. When I'm not online,
no,
don't
I'll
waste my
just
time.
repeat it now. I'll just repeat it now. So Wolfie's measurements
Okay,
were that
goodbye.
30, so Wolfie's measurements were that 33 feet of that there should have been 33 feet hidden and 63 feet showing. Okay, so he was deceptive in the fact that he was only using 63 feet to the focal height, when really there was probably more like about 80 feet where it had to go to, like to the top of the lighthouse, right? And 33 feet would have been showing that at least 4 to 6 meters of land should have been visible. There was no land visible at all. So the prediction of what Wolfie was saying was wrong in the first place. See how AK dropped out when that part's going to be mentioned? He doesn't want to mention. He doesn't want to go over the fact that the prediction that Wolfie had was wrong. Yeah, it was a whole thing of like 3 hours last night and now 2 hours this morning going over this. But yeah, if you were to see the video that it was, Wolfie's numbers that he showed that there should have been 33 feet hidden. Well, 33 feet is only 10 meters. The lighthouse is about 16 meters to 18 meters above sea level. So if only 10 meters was meant to be hidden, then there should have been, you know, anywhere from, you know, sort of 4 to 8 meters, depends on where you check. Google Earth has different levels. But there should have been 4 to 8 meters of land visible. There was no land visible. We had an inferior mirage. Then he just claims that the entire lighthouse was visible, and clearly the entire lighthouse is not visible. And he's just trying to manipulate it to point it to the spot where it's going right at the base of the lighthouse. It's not at the base of the lighthouse. It's a few meters above the base of the lighthouse. And now he doesn't want to discuss it. He just wants to run. But anyway, let's change the subject. Any new discoveries, Essie?
What's up?
Has there been any new discoveries on the dark matter front or anything like that you've been chatting about? Have you seen anything new in the past couple of days?
Past couple of days? No, not really. No. Their cosmology's in trouble, like it always is. They're scrambling to come up with excuses.
Sounds like AK. Scrambling to come up with excuses. And then rage
No,
quit.
AK's back. AK maybe had to do something. Welcome back. You guys could go at it if you want. But one at a time, for the love of God. You have the floor.
Yeah, well, AK doesn't really like to not interrupt. Do you want to tell him what the prediction was then, AK? What prediction did Wolfie say? 33 feet should have been hidden? Was that Wolfie's prediction, AK? When I get home, I can just take a screenshot and put it on and show that 33 feet was his prediction. It's in his video.
Refraction, wasn't it?
Sorry?
Standard refraction, wasn't it? I mean, we've gone through this like 100 times now.
Yeah, but that
Don't
was
waste my
Wolfie's
time, please.
prediction. Was that Wolfie's
Don't waste my
prediction or
time.
not? Was that
With
Wolfie's
standard
prediction
refraction.
or not?
We was saying with standard refraction. Is standard refraction present when an inferior mirage is present? He did not discuss this. Yes, we agreed on that already.
He did not mention the inferior mirage. He just used standard
Indeed.
refraction as his prediction. True or false?
He used standard refraction. I don't know if he used standard refraction as his prediction. I think he, but the main point is that he mistook the height of the tower. That he mistook the height of the base of the tower as the focal height minus the height of the tower, which lowered the base of the tower, which incorrectly lowered the base of the tower. But we've moved past it already, and we've analyzed the footage and the numbers further. And it just so turns out that coincidentally, expected observation would be so that you don't observe the land below the tower in this particular conditions, most likely, according to what I can find. And
Yeah, but even the thing
that
that
is
you
also
worked out,
what you're
sorry.
observing.
Okay, but even the thing that you worked out said that 59 feet should be missing. That's not even including an inferior mirage. That's just pointing to where the horizon should be. So there's no prediction of an inferior
Yeah, we
mirage there.
can. The calculators that you're using to make predictions do not predict any sort of miraging. They also don't conflict with them.
No, those calculators will never predict an inferior mirage or a superior mirage.
Exactly. That's simply
It's
not in
obviously
the capabilities of that calculation alone. For that, we have to do another analysis and we have to dive deeper into the topic. I already told you that as well. Don't waste my time, please.
so. Then a 59 foot prediction from what you did, even though that was from close to 10 meters above the observation point of what we're observing. Okay, so 10 meters below, obviously there would be different temperatures, so you'd have to get a different thing, and then 10 meters below that there would be different, and 10 meters below that it would be different again. So we can't really use something from 40 meters. But I get that that's the only thing that you have. But then if that's the only thing that you have, then you can't use it really. It's not admissible.
Yeah, it's not admissible. But your hand waving and wishy-washy is admissible. You're not even like trying to figure it out. You're not even presenting any numbers. You're not even presenting any reasoning. You're just going, nah. That's all you do.
No,
And I'm
that's not
tired
what
of
I'm
it.
doing
I'm
at all.
sick of it. Yes,
That's
that's
not what
all
I'm
you
doing at
do.
all.
That's all you're addressing. You go to
Dude, nobody said the words
prediction
nuh-uh.
that's obviously
Nobody
incorrect.
said the words nuh-uh. It sounds like there's a lot of substance with what's being said. So nuh-uh is really nothing that anyone
Sounds
is
to
saying
you,
at all.
maybe.
So it's not really.
That's your problem.
Seems like you're just ad homing or trying to randomly make up a straw man.
Exactly.
This is not a conversation that's fresh. This is a conversation that has been going on for 2 days and has been repeated 50 times. He says prediction mismatches observation. I asked him what he derived to predict, what he used for the prediction. He said the curve calculator. I point out the curve calculator A will use no refraction or standard refraction, both of which are not present, obviously, in this observation. He's saying prediction does not match observation.
Well, if you actually look, the
He doesn't
prediction
move
doesn't
past
say
this.
the prediction of the calculator that Wolfie used when it goes into severe refraction actually shows you being able to see more of the land. All right. So when it gets to the most severe
downward, upward refraction is inferior
I
mirages
do recall that I was still speaking, Aiken.
inferior mirages are an indicator of upward refraction, which would be
You just want to
extremely
take over the
weak
conversation.
refraction.
Okay, so
I'm tired of this.
Let me
It's been
just
repeated
repeat.
50 times.
No, it hasn't been repeated 50 times. Okay.
Yes, it has been repeated 50 times.
So,
I'm tired of it. Please don't waste my time.
So the calculator that Wolfie used shows that with severe refraction, only 2 meters should be hidden. With no refraction, 17 meters should be hidden.
Severe downward refraction. Inferior
That's
mirages are an indicator of upward refraction, which would go in the direction of extremely weak refraction of the source that Wolfie was using.
Well, upward refraction actually means that you have more hidden.
Yes, exactly. Finally, you're arriving.
Yes.
Only needed 2 days. Good job.
But the thing is that your calculator doesn't show that. The calculator doesn't show with this, you get that, with this, you get that. It only goes one way.
Actually, it does. How do you think I got the prediction that I presented to you? How did I get the prediction that I presented to you?
What does Wolfie's calculator
Saying
do?
it's inadmissible.
What does Wolfie's calculator do?
source that he used presents a few options of like a little bit weaker than standard and a little bit stronger than standard refraction. This is not the entire range of ambient conditions that can occur, and the source also does not claim that.
Right,
The
now
way you in a prediction is still insufficient, is still incorrect.
And once again, you using the numbers that you have used is also incorrect. It's not admissible.
What? Oh God.
Okay, so that's also not admissible.
The temperature gradient is unstable. It's a temperature gradient that falls too steeply. That means the temperature gradient needs to be driven by the sea, needs to be driven by the temperature delta between the ground and the air above it. That means the temperature gradient was expected to get steeper than what I found, and it's lower to the ground, closer to the ground, rather than less steep. That means the refraction that I found is expected to get even the upward refraction or less than normal downward refraction that I found is expected to be even to be slightly more than what I found according to the numbers. That means that even a little bit more than the base of the tower is expected to be in hidden height, which matches the fucking observation. Qualitatively, and as far as we can tell, quantitatively, the observation matches prediction. All you go is, yeah, but the prediction that I have is a prediction that's not even expected to occur when you actually take the facts into consideration. Yes, Wolfe made a mistake. Yes, Wolfe incorrectly calculated how high the base of the tower is expected to be, and then incorrectly concluded if there should be land below the tower visible or not. And this all happened to work out because he did not look into the refraction, or he did not look closely at his observation. Why he did that, I don't know.
And he also incorrectly stated that the entire lighthouse is visible when the entire lighthouse is not visible.
No, that is not incorrect. All the evidence points towards the fact that the mirror line is just above the base of the tower.
I would say it's a few meters
Only
above.
evidence that you have presented is an analysis of the relative features of the using the relative heights in the features of the tower, which you yourself debunked by pointing out that stooping and towering can distort how tall a certain section of target appears to us. A much better tool is to use the landmarks left of the tower, because the refraction and the mirror line is not expected to jump up and down in a relatively small field of view left to right, and the stretching of one landmark is not expected to be suddenly different in the middle of the field of view compared to just left and right of it. So we can use the features, the shapes of the land that we see left of the tower to determine, okay, what relative height do we see the mirror line at? That appears to be just above the base of the tower. There's no way around this. The only thing you has said in response is nah.
No, I'm not saying that. I'm saying that mirror line is a few meters above the base of the tower.
You never substantiate it. You only go, nah, it's not just above the base of the tower.
we basically
never
got the thing and
quantified
drew.
it. You never actually substantiated it with sound reason. You only go, yeah, your view is different, the angle is different. Yeah, no.
Oh, you're saying
you
it's
can
not.
still identify the land masses. You can still identify relative heights of the land masses to the tower, and you can therefore see that the mirror line is far below what you claim it to be.
Okay.
End of discussion.
So no, not end of discussion. So what I actually said to you was, at best, what you did because I think I said originally more like about maybe 7 meters of the tower was hidden. I said at best what you did was you lowered that down to more like around 3 meters of the tower hidden. It's not at the base. Okay.
Okay.
Right.
3
It's
meters
still
is
not
close
at
enough.
the, well, it is close to the base, but it's still not the entire tower, right? That was Wolfie's claim.
Well,
Wolfie's claim was
it's not
the
expected to
entire
be
tower.
exactly.
We're going on Wolfie's claims. Wolfie's claims was that the
Well,
entire tower.
Wolfie's analysis was faulty anyway.
And
We
now we
moved
can
on
also
from this
clip
long
this out.
ago.
We can also clip this out and say that you said the entire tower was also visible.
I said close to the entire tower. I always said the mirror line appears to be just above the base.
Just
1,
above.
2, 3 meters, and I did not quantify it exactly, but it's like very close to the. It's relative to what you were initially claiming, close to the base.
Okay.
And that matches relatively closely again. Not exactly, obviously, because we don't have the exact numbers to determine it for sure or anything like that. And even if we were able to determine where exactly the mirror line is and what exactly the prediction is, then we would still not be able to conclusively say if the observation matches that or not, because we have an inferior mirage blocking the view below the mirror line. So we don't know what would be visible without the inferior mirage below the mirror line. Would we see more land there, or would we see a horizon appearing to cut off the tower at the mirror line? We don't know that for sure.
Well, we would see more land there because I can tell you with 100%
You're saying
accuracy
that without substantiating it.
that an inferior mirage always raises the appearance of the horizon. And that's
Raises
not
the appearance of the
unsubstantiated.
horizon. What do you mean with raises it? It lowers
always
it
raises
because
the
it blocks.
No, an inferior mirage raises the appearance of the horizon.
Where? To the mirror line?
No, to where it would be appearing on whatever land or anything that is behind it.
Oh. So to the mirror line.
How many videos would you like me to drop demonstrating that the horizon always raises in the appearance to the objects behind it when there is an inferior mirage?
Raises in the appearance to the objects behind. What the fuck does that even mean?
Okay, let me give you a demonstration then, because I can't do it on my phone right now because I'm somewhere and I only have my phone. I don't have my laptop. But
Maybe
the observation
work on your communication skills.
The observation that I have shown in the past of the land 15 miles away from me, and I've shown it from less than 1 foot observer height. I have observation of that where only about 2 meters is obstructed. And then I also have observation of that where more like about 150 feet is below the mirror line. Now the appearance of where the horizon is, when the mirror line is there, is more at around the 130 to 140 foot mark. But the horizon, according to the actual globe prediction, with standard refraction, yes, the horizon line should be at closer to 100 feet. But the horizon line appears to be at more like 130 feet and the mirror line more at 140 feet, demonstrating that the appearance of the horizon is higher than the prediction of what the globe says when there is an inferior mirage. Is that clear? Was that clear enough for you?
And that would be expected. Because again,
so then you're in agreement with me
that upward refraction is present, which would increase hidden height.
So then you're in agreement with me that an inferior mirage will always raise the appearance of the horizon.
It's a stupid wording for that, but I guess
it's not. How would you word it then? Word it in a more intelligent way then for us, please.
I just worded it the way I would word it. I don't know what you want me to do now. Should I repeat it? Like, don't waste my time, please. Let's move on.
You just said, upward refraction will do that. Sure. Okay. Now, what I'm saying is basically the same thing. When you have an inferior mirage, the appearance of where the horizon is always raised higher than what the globe would predict the horizon is.
See, that's the hidden height, like the height that appears to be obstructed by the horizon, the height of objects, and where it appears relative to eye level are two different things. The upward refraction is expected to increase the hidden height. It's also expected to lower the apparent precision. And you were conflating them somehow. This is a very, yeah, that's
No,
why I think it's a stupid wording.
and therefore then the appearance of the horizon is higher than what it should be, right? Do you not understand
Should
that,
be.
what I'm saying?
Again, what it should be is determined falsely. Therefore, that's a nonsensical way to phrase it again. What if you say it should be that, then you will have to consider what it should be with sound reasoning. You should not take a presumption that you already know is false and then go like, look, it doesn't match with what it should be, because that's not what should be means. Should be means it should be that way, which means you couldn't to take all the factors into consideration that you can possibly you take everything into consideration that you know of, and then you make a determination what should happen according to that. If you only
Okay,
take
then
part
what
of
I
what you know of what you think should happen into
okay
consideration, but
remove
know something else that you need to take into consideration, but don't
remove the
take it into consideration, then what you determine is not what should be, because there's something else influencing your result that you know you should take into consideration but didn't take into consideration.
remove the word should be then with what the globe prediction is. So let's just say with standard refraction,
Globe prediction,
the
that's
point of
not the globe
you're now
prediction.
interrupting me again. I just let you monologue for like a minute. Stop
That
interrupting me.
because you
Okay,
repeat the exact same bullshit again.
okay, stop interrupting.
You repeat this
Is that
exact same bullshit. You do not address the point being made. You just repeat your bullshit ad nauseum as if I have not said anything.
I'm addressing your thing?
It's
I'm addressing your
frustrating.
thing. I'm addressing what you said. I'm trying to clear up. Get rid of the word should be. Go to the word. Go to where the prediction of what the globe model says where it is meant to be. That's what I
Where
mean
it is
by what
meant to
I'm
be is
saying.
just a rephrasing of should be. That's not getting rid of it.
It's the globe prediction.
No, it's not.
When
It's a
you say
prediction under standard reflection. If you know that standard reflection is not present, then that the prediction does not hold. It's not expected to occur. It's that simple.
then when you
If you
have an
know the
inferior
conditions that
mirage,
that
once again you're cutting me off. And then when you have an inferior mirage, the horizon is higher, right?
the hidden height is higher, do not actually measure which orientation the horizon is seen in relative to eye level. That's a
Okay,
those are two different things.
I'm not claiming that the horizon is actually higher. That's why I say the appearance
That's what you keep saying,
of
though.
the horizon. I say the appearance of the horizon
What's the
is
difference
higher.
between what's the difference between appearance of it and it being higher? Horizon is inherently an appearance because it's defined as the line where the sky and the ground appear to meet.
Well, something being
Technically,
higher.
all the way between
Actually,
you and the horizon, there is sky, but you don't see it as sky
if I
because
was to
all the
say
air
something
around
is,
us is part of the
are
sky.
you fucking right, bro? Can you let me speak? You have to interrupt all the time. It's really frustrating. Oh my
Consider
God.
that there's a lag between us, maybe.
Okay, then just stop talking for a moment. My God. So frustrating. Okay, now I forgot what I was even going to say. Okay, so if we use the word something is higher, that's an actual, like we're actually saying something is higher. If you say something appears higher, you're not saying that it is, you're saying that it just appears that way, right? So if I say
Horizon is
this is higher than
inherently an
that,
appearance. It's inherently where the sky appears to meet the ground. The sky meets the ground everywhere because all the air around us is part of the sky.
okay, but that's not what
So
we're
with
talking.
regards to the horizon, there's no difference between appearance of it and it being, because the horizon itself is an appearance. It's not actually the thing where the line where air starts to make it different from ground. All the way between where you are and where you see the horizon, all the way between it, there's air, there's technically sky.
Okay, so when we see an object, and let's say as an example, the distance that
Horizon
it
is not
is,
an
standard.
object.
Did I say the horizon? I said when we see an object, right? Stop interrupting
Go
me and let me
again
get
with
the point. Again, you're interrupting, AK.
just
Dude,
repeating.
seriously. I'm trying
Yeah,
to
this is
explain
getting
something
out
to
of
you.
hand. Okay, this is getting out of hand, bro. Seriously, you either you're gonna do it or I'm gonna mute you for like 5 minutes or something. We can't just keep babysitting you, bro. You have the floor to yourself. That's a rare opportunity here. Come on, man. Behave, please.
Okay,
Read
Go
out
on.
again, please.
I'm just trying to establish that something appearing to be higher and something actually higher are two different things, right?
Yes.
Oh, so you agree? Okay. So when I say that the
What are you
horizon
talking
appears
about?
to be higher in relation to something behind it, I'm not actually saying that it actually is higher. I'm saying that it appears to be. I know that the horizon is called the apparent position where the sky meets the ground. That's apparent. We know
Okay.
that.
All right. So, since the horizon is an apparent position of something, right? It's not an object. It's an apparent position, right? Can you point
Yeah.
out the difference between apparent position of something is higher, right? And appearance of something appears to be higher.
Oh, they're the same thing.
Oh, and that's what I've been
Something
pointing
is
out to you.
something
With
is
regards
apparently
to the
higher.
horizon, since the horizon is an appearance, it's an apparent position in the first place, and it appears higher, it is higher because the horizon is not an object. When we're talking about a horizon, we are already talking about the appearance. We are already talking about an apparent position. It appears higher, it is higher.
Real quick, when
It
you guys are
appears lower, it is
talking
lower.
about the horizon, are you talking about the when you guys are talking about the horizon, are you talking about the last little bit of ground you can see? That's the actual thing that you're talking about, the object, right?
The
Yeah.
horizon is the line where the sky and the ground appear to meet. Obviously,
Yes, and
within
where
the
that
scope of
line
this
is, there's
discussion,
an
we are assuming free and clear view.
and where that line is, there's ground, an actual object, an actual physical object.
Yeah, but it's an apparent position.
Yes, and sometimes that object
Yeah,
will
we know
appear
that.
to be lower or higher.
Yes, but it's the apparent position is what we call the horizon in the first place. So when it appears
And
higher
when
or lower, it is higher or lower, the horizon, not the object itself, the horizon,
well, the
not the
horizon is
object
not
that
actually
that builds the
the
horizon.
horizon is not actually higher or lower. It just
Oh my fucking
appears
god,
that
you
way.
contradict yourself.
But the horizon
What
isn't
is the
actually
horizon?
higher. The horizon isn't
What is the
actually higher.
horizon? What is the horizon?
We all know that. We've
The
been over that 100 times.
Is the horizon an apparent position or not? Yes or no?
Yes. AK.
Yes, it
The
is an
horizon
apparent
is an
position.
apparent.
Okay, when an apparent position appears higher, is that apparent position higher, or yes or no?
The apparent position is higher, but is it actually higher?
Exactly. Exactly. The horizon is an apparent position, though, isn't it?
That's what I've been saying the whole time.
My fucking God. When the apparent
That's what I've
position of
been
something
actually
is
saying the
higher,
whole
then the
time.
apparent position of it is higher. The horizon is an apparent position. When it appears higher, it is higher. When it appears lower, it is lower, because the horizon itself is the apparent position. It appears higher, it is higher. When it appears lower, it is lower, because the horizon is the apparent position. And then you can't go back and
No,
say
the
the
ground.
horizon does not
No,
is not higher or lower. No,
no,
the
the object in the
horizon is the
background,
apparent position.
the object in the background is what is actually appearing to be higher, or is what is actually appearing to be higher or lower, which makes the appearance of the horizon seem higher or lower. But the horizon isn't actually
You
changing its
seem higher or
position.
lower.
The object in the background is changing its position higher or lower.
No,
The horizon
the
isn't
object
changing
does
its
not
position.
actually. No, you got it mixed up. It's not the horizon that doesn't change its position. The horizon is the apparent position. It does actually change its position because when it appears higher and when it appears lower, because it's the apparent position. It's the object that does not actually change its position. It stays in the same location, but it appears higher and it appears lower. That makes the horizon appear higher or appear lower, or seem higher or seem lower. But the horizon is the apparent position. Therefore, when it appears somewhere else, it is somewhere else. The object that constitutes, that makes up the horizon, or by which we identified the horizon, that does not actually change position when it appears higher or appear lower. Right?
Well, we know that the object doesn't
Got it mixed
actually
up.
change. We know the object doesn't
Exactly.
actually change position.
Oh
The
my
object is
fucking
where it
God.
is.
Yes. Oh,
The
I
object is
just
where it is.
told you that you got your wording mixed up. Just move on, dude. Just
Okay, we
move
know the
on.
object actually is where it is, right? Clearly, the object isn't going to change its actual position.
Well, we don't actually know how the distances and orientations relate to each other, because that's the discussion that we're having, right? What's the observation? What's the prediction? And what's real? And how? What understanding of reality is the closest to the truth? We have
Right
actually
now,
not known that and taken that as known.
now by going into the fact that the horizon can change its apparent position constantly, then we can't use it to determine whether we're on a curved surface or a flat surface, because it's constantly changing.
It's a bad tool, yes. It's not impossible to use it, because you can determine the influencing factors. You can try to see if there is corridors of conditions or borders of physically of arrangements that are insensible, or that are more sensical, or you can actually try to build a grid of measurements of ambient conditions to a high enough accuracy and resolution to know the light path between the observer and the target, and then you can actually construct which geometry must be true according to that. So it's not impossible, but it's implausible. Yes, it's a bad tool for figuring this
Right.
out.
So therefore, then using something blocked by the horizon doesn't prove that the Earth's curved.
Just stand alone in itself without any deduction, no.
Therefore, then, considering that the
Okay.
horizon is just an apparent position, and we can't determine that it would prove the Earth is curved, it then also demonstrates that there would be a horizon on a flat Earth.
No.
Because it's a changing position. It's a constantly
No.
changing position.
Just because something is a changing position and is apparent does not mean it should occur the same over different understandings or different models of the Earth.
Well, you've just contradicted yourself.
Not correct. No,
You
I
just
did not.
contradicted yourself. How can you
No,
turn
I
around
did
and
not.
say
You
that
just pulled a
it's
non
not?
sequitur.
How can you say that it's not something that can be used to determine that the Earth is curved, and then also state
God.
that we can't then state that it would also be something that is
You're
viable on a flat
ignoring
Earth?
like 2 minutes of something I said.
Not
I'm tired
ignoring
of
it.
it. Stop wasting my time. Ignoring like literally 80% of what I'm saying.
No, it's actually
Actually,
going right along
sometimes
with what you're saying.
you respond to something. Do you respond to me explaining how what you're saying is wrong with repeating what you've just said again without addressing any of what I said?
No, what I'm doing at the
I'm
moment
tired of this.
is
I'm
showing
tired of
how
this.
what you've just said also demonstrates that because the horizon is a constantly changing
No, it
position,
doesn't.
and then the horizon isn't a constantly changing its apparent position.
No, that's not what I'm saying.
Didn't we just have this entire discussion for 5 minutes? So that's what it does. It changes its apparent position because it's apparent. Remember?
I'm not saying that it does not change its position. Double negative. Dude, keep up.
Sorry, I just thought I heard you say that it now doesn't change its apparent position.
Yeah.
So it changes.
No, I did
So
not
it
say
changes
that.
its apparent.
I did not say that.
Okay, so it
Keep
changes
up.
its apparent position. Therefore, then, if it changes its apparent position, and we can't
Fucking
use
dimwit.
it, and we can't use the horizon then to determine whether or not something being blocked by the horizon is due to Earth curve, which you admitted is not a good measure. Therefore, then that also demonstrates that you would have a horizon on a flat Earth because it is a
That
changing
is a non
position.
sequitur. That
They're
is a non
what's
sequitur.
non sequitur.
No,
They
it is a non sequitur. Hey,
they can be
logically,
put
what you're doing,
together.
hey, stop. Logically, what you're doing is A, therefore B, and we have a completely separate thing, C, B, therefore C.
Hey.
That are separate things. A, therefore B does not prove B, therefore C. Okay?
No, it also doesn't disprove it either.
I'm not saying it disproves it, but what you're saying, what you're laying out as your reasoning, as your evidence, is not logically coherent. It's not connected. It's a non sequitur.
No, it actually is logically. Viable.
The fact that we, from observing the horizon alone, don't necessarily know what the shape of the ground is, that the geometry is that causes that observation, because there is a variance in the light path that makes it those are two variables that can interact with each other in different ways, so that multiple explanations are possible. Does not mean that therefore your explanation is also possible. You need to substantiate that first separately, because it's a separate issue.
It's substantiated in the fact that the horizon is a
No,
always
it's
changing
not.
position.
No,
Don't
it's
interrupt
not.
me.
No,
Yes,
it's not.
of course it
No,
does.
it's not. No, it's not. You
It
need to
makes it a
substantiate that
viable.
separately. The fact
It makes it a
makes
viable
the
option.
possibility, but it makes it a possibility, but
Thank you. That's all we needed. Thank
it
you. It
makes
makes
the
it a possibility.
no, it
Thank you.
makes the
Thank you for that.
And you
We all just heard him
let
say
me
it makes it a
finish.
possibility. So therefore, it
Okay,
makes it a
so
possibility. Therefore, it's possible, right?
hey, shut up. Makes it a possibility, but making a possibility is not a proof
Hey, why don't
that
you
it's a
shut up?
viable option. That needs to be substantiated separately, as I've been telling you all this time.
Okay, but you've just admitted
Not
that it
that
makes it
hard.
a possibility, right?
Fucking God.
It makes it a
But it
possibility,
doesn't
right?
prove it doesn't prove that therefore it occurs. You need to
Okay.
substantiate that separately. How many more times?
Just as the appearance of the horizon blocking something does not prove that it's being blocked because of Earth curve. Right?
Oh God.
You already
So
admitted
what's the
to that.
point of this? What's the
Okay, so
point of this?
now we've established
What's the
that
point of this? Go
a
on.
horizon on a
Move
flat Earth
on.
is perfectly
Go on.
viable.
Move on. Move on.
Now we've established, and you've admitted that
Move on.
a
Move on.
horizon on
Stop
a
talking
flat
about
Earth.
the past. I'm not gonna engage with you anymore if you keep
Okay,
repeating the same bullshit over and over.
I'm just repeating it to just
Stop
to get it out
repeating.
there.
Move on. Last warning. Move on.
No, it needs to be repeated. Don't tell me what to do. You know, you don't get to control what I do. You just get to listen for a moment and don't interrupt. So you've now established that a horizon is perfectly viable on a flat Earth. It's something that's perfectly possible, and that something being blocked by the horizon does not mean that the Earth is curved. These are the two things that we can now get from what this discussion has just produced. So we can flip AK out saying that it's perfectly possible. That's all.
I
I'm happy with
have
that.
muted him, but now he's unmuted, so you can speak, LK. Okay, but don't interrupt.
That's it. I'm fine. I'm done. We got the admission that a horizon is perfectly possible on a flat Earth, and that the horizon blocking something doesn't mean the Earth's curved. That's good enough for me.
Well, he's free to speak if he wishes. I guess that's enough for him too.
I think that's a reasonably big admission there from AK. I It would have to be one of the first times we've got a glober to say that a horizon's possible on a flat Earth, and that the horizon also doesn't mean that the Earth's curved, or something being blocked by it doesn't mean the Earth's curved.
Well, let's give him the benefit of the doubt. Maybe he's busy, or give him a while to respond.
Well, I mean, they're his words, so whatever he says is just going to be excuses for making up, trying to explain away what he said. Anyway, I'll just listen in, but it looks like my battery's probably about to die. So we can end that now. You guys can
I see you're finished repeating, finally. Appearance of an apparent position changes. It's not the apparent position that changes, just the appearance of it. How stupid. Simon, can I ask you something?
Sure.
Alright, so I keep hearing you make comments like their cosmology is in dire states and they're scrambling and they need to make up tons of things and stuff like that, right? And what you seem to substantiate it with is with like things like dark matter and dark energy. The fact that is simply um, the understanding that they're building is seems to be having holes such that they just have this gap fillers or this like, okay, according to the calculations, we have to have this matter and this energy, otherwise it doesn't really work out, but we don't really know how it all fits together. How is that different from recognizing that you don't know what the sun is, what the moon is, what the stars are, and how they work, why they work the way they do?
I'm not sure I understand the question.
Okay. Know how we can't actually take samples of the sun or the moon or stars, right? So
How
we
you
can't
cannot
really
take examples? How you cannot take
samples.
examples? Yeah, right. Okay.
Samples. Yeah, you can't take samples, right?
Samples.
You can't like take
Correct.
yeah, you can't go there physically, take like a piece of it, right?
Right.
So um so we don't know why they occur exactly, how they work, and why they work the way they do, right? Can't know that for sure. Can't know that with certainty because we can't take a piece of them and go like, oh, that's what the sun is.
Yeah, exactly. Yeah.
So okay. So how is that realization and that knowledge any different from the realization that, hey, what we from the understanding with the dark energy and dark matter is? Because it's basically the same thing from my point of view, kinda. You're going like, okay, we have all this understanding, and the understanding as we have it this way, for the extent that we can interact with it, seems to work out and it seems to be beneficial, right? But we have this ever gaps that we fill with what stuff that we know so far, but we can't really confirm, deny, or investigate it in any form. That's what dark means. Dark energy, dark matter means we can't interact with it and we can't investigate it or find out what it is. of our capabilities. How is that any different from the realization that we can't take samples of the sun, moon, stars? We can't know how they work and why they work. Why is the dark matter and energy mocked? While your realization of, hey, I can't take a sample of the sun and I will never be able to figure out how it works, any different?
Well, it's both. You're correct in both instances. They don't know what the sun is for sure, and they don't know what dark matter and dark energy is. So yeah, that. Why are you surprised on that?
I'm not surprised. I'm just wondering why I keep hearing you make dismissive comments and like kind of joke around about this dark matter and dark energy stuff and so on, being like
They're not
you always
dismissive.
paint this picture of it's in dire states and stuff, right? But at the same time, your own word in our own, like you and my worldview for what we know that we can't figure out the sun, the moon, the stars. You know? How is
Exactly.
that different?
You're
Why do you
making
not
my
mock
point
that?
for me. You're making
Huh?
my point for me.
Okay. The point I'm making is that I hear you mockingly talk about dark matter, dark energy, and their cosmology a lot. But
It's
I
not
don't hear
mockingly.
you making this.
It's okay. It's not mocking. It's saying the truth. It's saying what your scientists have found. I'm not mocking it.
You clearly color it.
Sorry?
Color it. Like you saying it's in dire states. I have never heard you say that
It
about
is. Well, it's a
the
fact.
realization that. I've never heard you say that about the realization that you can't take a sample of the sun or the moon. I've never heard you say
Did you
that
say he's
about
colored?
the fact that we don't know why the bodies behave the way they do.
Yeah, he's trying to say Dark Lives Matter. That's what he meant to say.
Well, okay. That's another example of this mocking tone. Yeah.
Okay, that was a joke. I mean, come on. But
He called him
when I
colored. What do
say
you want me to say? In America, that's called
Okay,
racism, AK.
what I'm curious about is the balance of jokes, because you seem to be disproportionately mocking, joking about one side of things, while you leave the other side of things that's exactly the same, basically the same side of the coin, alone. And I don't understand why.
Well, I can explain to you why. Because your model, when I say your model is in dire straits, right? It's not mocking. It's not. It's a fact. Check your scientists. Have a look. Check around the YouTubes. Do some research. Read the papers, and you'll see. Your scientists say this. It's not me. When I talk about the baby galaxy paradox, the black hole problem, the early development, galaxies in the dark ages, this is not me mocking or making it up. I'm telling you what your scientists are saying, bro. So
I'm
I don't
not
know how
saying
you.
that this is mocking it. I'm just saying how you like keep talking about that, but don't even like. There's tons of other things to talk about that are also worthy of bringing to the topic. For example, the lack of progress and the lack um, of findings in the community. How the truth community keeps proliferating instead of unifying, converging towards the truth. It keep there's more and more and more diverging ideas coming up, but there's nothing like almost nothing that people end up agreeing on. Isn't that a problem as well?
Well, that's you're
And
changing the subject in a way now, but yeah, we can discuss that if you want. But I mean, as far as the cosmology goes, I mean, your James Webb plane telescope, like I call it, I mean, it's pretty damning to your cosmology. It's not my fault. It's not my fault, AK. It's your findings. It's your model that's in.
I'm not,
Yeah.
fuck. Okay, you're wrong near assigning a model to me in the first place. You keep doing that, but it's okay.
Okay, the cosmological model.
The topic was that I was asking you why you keep talking and keep joking and bringing up their cosmology and all of those things. And I rarely hear the same like kind of scrutiny and the same kind of like somewhat savage treatment towards our ideas and towards our things that are also worthy of bringing up. I don't understand how you like why there's such a focus on joking around about their cosmology and what most of the world believes if you transcended it in the first place. Why is it such a big topic?
I don't know how many times I have to say it because it goes against the cosmological model. It's a big thing. If all this stuff, if the timeline of the cosmological model is wrong according to the findings, then there's a problem. I don't know why you don't understand, or why do you fail to see that? Let me ask you this. If you got a woman pregnant, okay, and you were expecting a baby in 9 months, and the baby was delivered in 3 weeks fully formed, would you have cause for concern?
Yes, but to keep with your analogy, I kind of already got together with that woman knowing that she is in pregnant in the 30th week.
3 weeks of
According
fully
to what you
formed.
guys are claiming.
You didn't hear me, right? 3 weeks, you would get a teenager. I said it wrong. I miss, well, I didn't fully speak. So you get a woman pregnant, and in 3 weeks, out pops a 14-year-old. Are you starting to comprehend the problem
That's
here
that
now?
super.
It's not that I don't
That's that
understand
super
that,
sperm.
dude.
Yeah.
I understand the issues that you're bringing up, and I understand why they are issues and why they are topics.
No, but do you understand that, I mean, AK, do you understand what I just said?
Yeah.
That's the problem, bro.
It's not to understand about it.
You're not too interested about it? What?
No, not right now, actually. You're still not really addressing the core of my question. Why? I asked you a personal question, to be fair. Do you not want to talk about that? It's okay.
Am I missing something here?
Yes, you are.
You asked me
Dude,
why.
You guys put together a mathematical
You keep
model
only
of
hearing
where we
half of
live.
my
Of
question for
course, you,
some reason. I don't know. Sorry,
Did you hear
I
Jeremy
don't know.
talk? Did you hear Jeremy commence to talk?
I'm sorry, I missed. I said I'm sorry, and then he
all right,
muted
just real
himself.
quick.
Sorry. Shut up.
Okay, fine. Just real quick. You guys built a mathematical model of where we supposedly live. Now, there's a problem with that mathematical model with new findings. SC is pointing it out. I think that's good that he's pointing this out to everyone.
Okay, you think it's good, but that's not the question I asked. I don't know how I can communicate it so that the complete question gets through. You keep only you keep listening only halfway. You hear I ask you why that and why the first half, and then you stop listening apparently, and then you just answer the first half of what I'm saying. But it's not the complete
Maybe I have
question of what I'm
wax.
saying.
Well, what are you saying exactly? Maybe I have wax in my ears.
All right. Remember how I was talking about there's our issues, there's this proliferation of the truth community, there's the lack of progress, and there's no truth that we can seem to converge onto and that we can seem to make use of practicality. Right? You said I was switching the topic. I was not. I was asking you why the focus is so much on this thing that on those topics we already know are false in the first place. We already know are made up in the first place. Why do I only hear you guys talking about that rather than about what actually matters, which is the truth?
Okay, so you're saying, okay, so if I understood you, you're saying why are we talking about made up stuff and not about the truth? Did I finally get you?
Yeah, I seem to I perceive bias between how this between this level of scrutiny and the level of between how those topics are handled. Like I would appreciate
No, I apply,
in
no,
my mind.
not fair, bro. I apply the same amount of scrutiny to everything. Have you heard me talk about the ISS? I talk about so
That's
many other things, dark matter, dark energy. I mean, how about a straight line? You want to talk about a straight line? Like, there's so many things that I talk about, bro. How
dude,
about the
you still
spacesuits?
don't get it. You still don't get it, do you?
Maybe I'm slow, bro. Maybe I'm slow. I gotta
Yeah,
be slow.
yeah. Okay.
Well, I don't know
So
about the maybe part.
there is information out there, right? The scientific community, the institutions, the public information, the public, the school, education, sciences, and so on, right? And that
Okay.
forms a worldview, right? In the end, right? That forms a certain set of statements, beliefs, and things, right? And in general, you know there's something fundamentally wrong with that. And all the things you've listed are on that side. And I am asking, why do you ever only keep talking about those things that you've transcended in the first place, that you've realized, that you've awakened from and realized that they are wrong? And don't focus instead on the other side of things that you don't know yet, that you can figure out the truth that matters.
Okay, fair enough. Like what? Give me one example.
Like that we don't know how the horizon works, why the horizon works the way it does.
Well, that's not difficult. We know the horizon is apparent. Simple.
Okay. That does
What more
not
do you want
explain
to
it.
know about it?
Okay. That does not enable you to quantify it or explain it or anything like that. It doesn't
When
even
did I make
enable
a
you to
claim?
differentiate it between different ideas.
Yeah, but when did I make a claim about the horizon?
It didn't say that you made a claim about the horizon. You just you just said it's apparent, which is self-evident because that's how it's defined.
Exactly.
But oh my fucking god. I asked why we don't even know why it occurs the way it does or how exactly it works. And
First of all,
saying
who
something
agreed
I
that it
self-evident
actually have a
won't
beef.
explain it.
I actually have a beef to pick with you about the horizon when you're done with this AK guy later. Shit is on.
Here we go.
You asked me for
So,
an example of what I would rather you talk about and
so you'd rather me talk
so
about the horizon? Seriously? That's your. I mean,
that was just an example. I mean, you really don't get what I mean?
okay, let's talk about the
That you keep
horizon.
talking about
What would you like to talk about the horizon? Tell me. What do you
It's
want to
not my
say about the
question
horizon?
actually right now. I asked you,
If you're not
hey,
going to go
it's
at him
okay
with the
if you don't want to
horizon, I'm
answer a
going to.
personal question, it's okay. I asked you a personal question and you don't seem to want to get it, and that's okay. But don't act like you're listening and then just try to deflect. That's
Dude,
uncalled.
I'm trying my best, but you're not being specific. You're telling me you'd rather me talk about certain things and not other things. And you gave an example, the horizon. And then I said, okay, let's talk about the horizon. Now you're telling me, well, you don't understand. And are you sure it's me that's not understanding?
Yes, I'm sure. Did not tell you what to talk about or not. I asked you why you treat why you treat this topic the way you do, and why you seem to have the bias the way you do.
I explained to you
He's trying
why
to
I
point out.
talk.
You just see
Go ahead, Esty.
the problems
No,
with
go on,
their
Jeremy.
worldview
Why
and their
would you think it's
cosmology
your?
as
Why
the
would he think it's
bigger
his turn to
issues.
talk again when we both started to talk?
Good point.
Okay, go ahead, Esty. Go ahead.
No, you were going on.
Well, I mean, I explained this earlier. They've built this mathematical model of this place we supposedly live in. Now there's things that they found that make this mathematical model improbable and impossible, and Essie's pointing it out. Like, I don't see what's wrong with that. He's pointing out
I'm not
fakery and
saying
trickery and bullshit.
saying there's anything wrong with it. I'm just seeing a clear difference in the quality of scrutiny, for example, between different sides of the fronts, so to speak. And I'm also
What should we
seeing
scrutinize more? Tell me, besides the horizon, name me something else that I haven't scrutinized enough. Like what?
Oh, don't try to get away from the horizon. I'm about to body you on this.
Well, yeah, okay, no
so
problem.
Besides the horizon, I mean, celestial navigation is also an interesting topic.
Celestial navigation.
Yeah, the fact that it works in the first place. The fact that it has haptic,
I've talked about that.
confirmable consequences.
Bro, I went on FED and challenged the 10th on that. What are you talking about?
All right, then I don't witness you speaking. Sorry, my bad.
Yeah, I was telling him about the magic book. But Nathan got all triggered, so that couldn't go on.
All right, so Jeremy.
Body bagging time.
Make it quick, though.
You ready? Fall back, AK. Watch how this shit's done. Now listen, is the horizon, that shit's a horizontal line? Is that what you think, Essie?
Appears that way, yeah.
See,
it appears
the
to be a
horizon
horizontal line.
is hold on. The horizon is the apparent location where the sky meets the ground or ocean. Jeremy. Definition.
Yeah, but it's not a horizontal line, though.
It's apparent.
Okay, well, never mind. I thought you guys were running around saying it's a horizontal line.
Yeah, the orientation seems to be horizontal. Like when you have eye level or an auto level for horizontal plane, that appears to be that's if you have a free view to the horizon, should be parallel to the horizon, to the line of the horizon. But the line itself is actually a circle. Because if you have a free view to the horizon all the way around, and it's going to be at the same, probably going to be at the same distance all the way around you, right? So it forms a circle. Apparent location forms a circle around you. What was so funny?
The parent horizon is a circle?
Hell yeah,
yeah,
bro.
it appears to form a circle around you.
All right.
If you have a free view in every direction, then the horizon should be at the same distance. Should appear at the same distance in every direction, right?
Give or take.
So you look all the way around you, and
it's your circle of vision.
Yeah. Well, of vision.
The question is, when does that change from being a horizontal circle that we see to the globe, to the curvature of Earth?
It's actually interesting. Yeah.
Now we're on, AK. Now it's me and you. SE, I don't know what I thought he thought.
Okay,
but
cool.
Now it's on.
Actually,
when does that change from being a horizontal circle to the curvature of Earth, the globe?
The line of the horizon on a globe, no matter which height you're over the globe, would still remain parallel to horizontal. It should still remain parallel to your horizontal plane. That doesn't change, right? But I think you're talking about when will it appear to be convex, and that's basically a similar question to like And you're seeing when you're standing in the middle of a hula hoop ring and you're seeing the inside of the ring side on, and it will appear like a straight line. When you lower the hula hoop ring or when you raise yourself, then you're seeing the circles more and more from above, and the circle will appear more and more convex to you. You will see it more and more clearly. Right? And that's
Yeah,
the
but with a
same
hula,
kind of calculation, I think.
Jeremy, can you ask him
yeah.
like yes or no questions so we don't have to deal with like 10 minutes of fucking monologues?
Oh, this is gonna take 3 hours. You better buckle up. So yeah, I understand. You look at a hula hoop, you raise up off the hula hoop, it appears to start curving, but that curve is the horizontal circle you're looking at. When does that? What I'm asking is on Earth, on the globe, when does the horizontal circle you see? When does that curvature change into actual Earth curve, the actual spherical curvature of a globe? How high?
What do you mean? I don't understand the question. I'm sorry.
We're standing on the ground. You're looking at the horizon. That's a horizontal circle you're seeing. That's the line. All right? Yes or no?
Hmm? Yes, yeah.
Yes. So when does that change? When do we stop seeing the horizontal circle? And when do we start seeing the spherical circle of Earth curve?
Okay, what's the difference between the spherical circle and the horizontal circle?
I don't know. Have you ever held a ball in your
He's
hand?
saying, yeah, he's saying drop, like basically like a drop angle, like something indicating dimensionality instead of just a two-dimensional circle or a ring, if you will.
Oh, that's what I just explained with the horizon appearing more and more convex. I don't know at which height it is to it should be to what degree. I'm actually still working on the formula for that.
Yeah, but when you come up off the hula hoop, you're seeing the curvature of the hula hoop. Like you're
Yeah,
just seeing
but
curvature of the horizontal circle. When do you stop seeing? What I'm asking is on Earth, how high do you got to get to where that horizontal circle curve is now Earth, the spherical Earth curve?
I think he just said he's still working out the math for that on the formula.
Okay, yeah, I mean, for how it convex it should appear to you, I still don't know what the formula is. I haven't actually found a formula for it, and I'm trying to work it out myself. I'm kind of
Oh,
busy
all
with
right.
other stuff right now, and but it
No
like
doubt. Let me
when
know
it
if you
appears
ever.
convex, to you, it doesn't stop to be horizontal, parallel to the plane to a horizontal plane, right? Like that, those are not mutually exclusive. That's why I got confused by your question. And yeah.
Yeah, it's a tough one. I don't know if I've ever gotten an answer on that. Bacon says we see it right away. Bacon says you're standing on the ground, you see the horizon, that's it. I don't know. I'm getting all kinds of different
I
answers.
mean, yeah, because your question is phrased in a way that you can interpret it in all sorts of ways. It's very unclear what you really mean.
Yeah,
I
you
think
got to
it's
kind of
because the
formulate it in a
understanding.
way, formulate your question in a way that's not so subjective, Jeremy.
I don't know what's
I think it's
subjective.
because
When you're looking at the horizon, you're seeing a horizontal. When you're looking at the horizon, you turn around in 360. That is you're seeing a flat plane. All
Right.
of that circle you see is all that circle you see, that's a horizontal circle around you. When does
Right. I
that
get that.
horizontal circle change into actual spherical Earth curve? Like
it
that's not
always
Earth
is
curve.
both, actually. It's always
The
both, actually. On a globe,
no,
it's always both.
the
Yes, the
circle, the
circle is
horizontal
horizontal plane,
circle,
forms a horizontal plane.
the horizontal circle,
Yeah.
the flat horizontal circle. That's not Earth curve. It's flat.
The circle of the horizon is a flat circle, and it's horizontal. No matter how high you get above the Earth, it will stay that.
Yeah, but he's saying when you leave the ground from that point, at some point you're going to start to notice that drop angle giving dimensionality to what it is what it is you're seeing. You're going to see where you left the ground being higher than the edges of that ring now. Now you have contour.
Okay. Yeah, the drop angle is not that hard to figure out actually. That's pretty easy. It's like at 60,000 feet, 2 degrees or 3 degrees or something like that.
Yeah, but he's
Quote
not
me
talking
exactly on
about
that, but it's in
measuring it.
that range.
He's talking about seeing it. Like at what
Yeah, yeah,
how high do you got to get up to start seeing that?
yeah. Yeah, it appearing convex. Like when you lower the hula hoop, that it doesn't appear as a straight line anymore, and you see that, oh, this is actually a circle. And that, as I said, I'm still trying to figure that one out. Apparently, there's supposedly people that can, with a high resolution, good quality rectilinear lens, and a straight reference in the frame, that can capture it already at like hundreds of feet of elevation. And consequently, you could also capture it with good equipment from a plane, but it shouldn't be apparent to you, your senses.
So
It shouldn't
so
be
what
perceived that way.
what kind of angle are you looking for, Jeremy? Like a top down or orthographic view? Are you looking for like more of a steeper side angle? What would you imagine if you could take a snapshot? Like how would it be?
I don't know. I just want to know when it changes from the horizontal circle to actual spherical Earth curve, the curvature of a ball.
Jeremy, can I ask you a question?
Go ahead.
Okay. Can you explain to me why you don't change the phrasing of your question at all? Like you use the exact same words and in the exact same order. You don't even try to make it a little bit more understandable.
I don't know how to rephrase it, dude. We're on the ground. We're seeing a horizontal flat circle, right?
Okay.
It's a horizontal flat circle. When you're out in space, you know the guys when they're way out in space and they look back and they see a whole ball.
Mm-hmm.
Yeah, that's actual Earth curve, or are they still seeing just that horizontal circle?
Well, yes. The circle that forms the horizon, like the part of Earth they can see, is still a horizontal plane. Still forms a horizontal plane. So it's still a horizontal circle. It's just much more obvious to them that it's actually a circle of vision that cuts into a globe. Supposedly, like obviously, it's all on the hypotheticals, but yeah. So that's my it's weird to me that you don't rephrase the question. Because actual curvature, like on a globe, the horizon is caused by actual curvature. It's influenced by refraction, which is why it can change distance and position, but it is underlying due to the curvature. So the horizon itself, that circle of vision, is the actual curvature itself, and it forms a horizontal plane. And that
So the
remains the
horizontal plane.
same over
Okay,
all
hold
altitudes.
on. So you're saying the horizontal plane is Earth curve?
Horizontal plane is your curve.
You just said that. You said when
the
we're
hori-
looking at the horizontal plane, that's Earth curve.
Well, that's again a weird way to phrase it. I mean, you could phrase
I
it
just
that way,
repeated
but
what
it
you
would be
said.
misleading in a lot of ways, potentially. Well, what I said is that the horizon occurs and forms due to curvature. Yes. So when you observe the circle of vision, appears due to actual curvature. It doesn't identify with it. Like curvature is not the same as the horizon. The horizon is always forming due to curvature. Like it's a one-way street, not a both-way street. And that circle of vision forms a horizontal plane always on a globe, right? And that remains the same no matter which altitude you go at. It just should become more obvious when you like at a really high altitude. But where the threshold is for it to become really noticeable, I don't really know.
Bro, I just took a phone call and missed everything you said. My bad.
Okay, sorry.
Yeah, he basically said he's not sure what the distance is.
Yeah. I don't
And then
know
he
where the
said
threshold is.
something about you being a bitch or something. I don't know.
Like, you know how they say you can't see Earth curve? You know they say you can't see Earth curve when you're standing on the ground?
Yes. I mean, does the horizon look curved to you?
No, it doesn't.
That's what I mean. You're not expected to notice that.
All right. So how high up? You're saying we could, if you got a good rectilinear lens or something, you could maybe measure it from a plane or something, or a couple 100 feet. You said.
Yeah. I mean, supposedly
All right.
there's some people that have shown it, but I don't know.
Answer me this.
Second, third
Riddle
hand.
me this. Listen, riddle me this. When do we know? How would we know if we're looking at the hula hoop curve or a ball curve?
That's a good question. Well, I guess when you get really far away so that the Earth as an object doesn't take up your entire field of vision. Like you can see left and right of the Earth while still looking at Earth as a whole. It
You can do
would
that standing
be
on the ground. Are you saying you back up so far where you can see the whole thing?
yes, exactly. Well, if it's a globe, then you can only see half at most, right? But at some distance, the Earth becomes small enough in angular size that it fits in your entire field of vision, right? And you see you see other stuff around the Earth all the way around. Like when you have a fisheye lens and you raise it.
So at the point when you could get the whole Earth in your field of view.
Yeah.
What if? Yeah, but what if that's just some kind of refractive effect, and you're still just seeing the hula hoop circle?
That's a good question. But at this point, if it's a similar question as what if we are living in a simulation? For me, if the illusion and if the fake is good enough with many enough overlaps to practical reality, or with many enough concerns for practical reality, then I will have to treat it that way. I will have to treat the illusion as the thing, as the real thing, if it's an illusion or not, because if it's for all practical concerns, if the illusion behaves as if it was real, then what's the use in saying, no, it could be an illusion? I could also
Well, I'm just
say,
saying there's a lot of optical illusions when we look in the sky. You know what I'm saying? We see stars appearing to converge and diverge. You guys say that's an optical illusion, not really happening, right?
okay.
I'm just saying there's like a lot of optical illusions happening, so I don't know.
Okay. Well, okay, but all those up, well, actually, to my knowledge, all of those optical illusions are reasoned or are overlapping with observing light from far away through a lot of air, right? But when you raise your altitude a whole
No.
lot, then you measurably reduce the amount of air that is around you exponentially. So there's also kind of like a one-way street, like looking at light from the Earth when you're far away from the Earth and can see the Earth as a whole thing. That is more reliable and less distorted than looking at lights that are far away from inside, from low down on the ground, where light has to travel through all of that air.
Bro, the stars appearing to converge and diverge doesn't have nothing to do with refraction.
Okay, so then I don't know what you're talking about.
Have you ever seen star trails?
Yeah. Well, have not captured them directly, but I know what you mean.
Yeah, we've all seen the pictures of star trails. I've never captured them directly either myself, but you can see if you
You ever
get
seen
in
Star Trails on weed?
but if you see star trails near the celestial equator, you can see the apparent convergence and divergence.
Oh,
You never seen that?
okay.
That's my favorite part.
Well, I know what you mean. Yeah.
Yeah, you guys say that's not actually happening, so it's got to be just an optical illusion. I'm just saying there's like a lot of optical illusions happening when we look long distance at things. So I don't know, like, if this getting the whole Earth in a field of view would do it for me or not.
Well, what they are saying is that you're just having one axis of rotation, right? And that you have 2 points that this comes out to on a globe, right? So you're having one rotation, and it's your perspective that changes. It's not an actual. It's not even actually an observed convergence and divergence.
No,
The
Earth's not.
curving away into 2 different directions is due to projection distortion.
Yeah, it's an illusion, you guys say, but I'm fairly certain Earth's not rotating.
Okay.
I have pretty
It's
good
not mutually
reason.
exclusive with the explanation.
What if the Earth was stationary?
The heavens could rotate around the Earth.
And you would still get that convergence and divergence appearance?
Yeah. It's still perspective in that case.
We're applying perspective to the stars?
Well, what would prevent us from doing that?
I don't know. I
They're
think they were having a
captured.
conversation earlier. Go ahead.
Like, I'm not saying that you are applying perspective to the relative positions of the stars or something. It's just the fact that you're capturing a wide field of view or something. Like you're capturing an area around you, and you're projecting it onto a plane. You're doing, for example, star trails.
Yeah, but
That's
if I don't know, it seems like you guys want to apply perspective to the stars when you want, and then when you don't want to, because we just had a conversation earlier today about the stars and perspective. And I once did a thought exercise where you have a pole. You know, if you walk away from a building, the building drops due to perspective, right? At least a portion, even in the globe model, at least a portion of that building drops due to perspective, right?
well, yeah. Naively, the part above the eye level would drop, and the part below would rise.
Yes.
Things
So
converge
the top
towards
of the
the.
yeah. So when you walk away from a building, even on the globe, the top of the building, due to perspective, would appear to start dropping due to perspective, partly.
Yeah.
Right. So now, in my thought exercise, you take a pole from the top of the building all the way to Polaris. Right. So when I start walking away, Polaris doesn't drop due to perspective at all, does it? You guys got that sewn up strictly due to Earth curve and all that.
Yeah.
Yeah. So, but with my pole, when I put a pole there, like the bottom of the pole is dropping due to perspective, but the top of the pole is not. It's touching Polaris. So that's not dropping due to perspective. So there's like a perspective gradient.
You know that the perspective is also subject to scale, right? So when you, for example, I look out on a street lamp from my room right now, and when I go, I'm relatively near this window. When I now go to the back of the room and look at the same street lamp, then it didn't really change in position because the distance that I travel relative to the height and the distance that the street lamp is at is relatively small. And perspective scales in that way. You have something that's like 100 to 200 feet away from you, right? And you change its position by like a few inch. And it didn't really move in your field of view a whole lot. And the same also applies to the drop, right? If you have something that's, if you have, for example, if you have a really big mountain and that you can see from tens of miles away, right? Then you can drive for like half an hour to the side of the mountain without it really changing its place. Or you can drive for, I don't know, 10, 20 minutes, half an hour. If you have a flat road in front of it, you can can drive quite a while before you notice the mountain dropping. So if the difference between, or for example, you're standing at the foot of the mountain, you need to look up at the mountain, right? And when you take 2 steps back, you need to look up the same amount. So when the distance that you travel is really tiny compared to the distance that the object is at, then perspective doesn't really make a dent.
All right. So where were we?
I don't know.
So if we could get up high enough to get the whole Earth in our field of view, you think that would be safe to say that it's a ball?
For me, I would be convinced by that probably, yeah.
You realize
hang on a
there's
minute.
only one
Wait a
time.
minute. In his paradigm, he's already done that. So
That's what I was just going to get into.
I didn't do that.
You realize the only time they've ever done that was on the Apollo missions, right?
Okay, yeah.
Well, as far as a human goes, I mean, they may have sent satellites or something to look back at it, but that's no easy task to just do that.
That's what I tell Coach's mom. I just say, look back at. Smack it up, flip it, rub it down.
Let me ask you this, AK. If I gave you $18 trillion and told you you need to prove it right now with a tangible measurement here on Earth, what would you do?
$18 trillion.
You fucking rob you.
18 trillion, bro. 27.
Okay.
Say you got 27 trail.
Okay.
Is this taxed
I'll
or
just
untaxed?
have.
We're off the books with this one.
You heard the man.
Prove it to you. Well, that depends. What do you need as proof?
No, prove it to everyone on Earth. Not just me, everyone on Earth. You
Everyone on
need
Earth.
something so solid. Yeah, you need something so fucking rock solid that it's undeniable.
Okay, I see. Well, I guess in that case, I need a very dense grid of measurements for air temperature, humidity, and pressure along at least one vertical plane between two between two stations that are like 1,000 feet ish, or like a few hundred feet away from each other. If I can build two more, that would be ideal too. And then I would measure the sight line and actually move the path of light between the two sightings, between the two surveying equipments. And yeah, then I would measure the angle between them, the zenith and the sideline. Correct it so that the the reference line between the two stations is straight. Then I would also measure the horizontal. If I have two more of those grids, then I would also measure the horizontal angle between between two landmarks at each landmark. Like I have three landmarks A, B, C, and I would go A, B. At A, I would measure the angle, the horizontal angle BC, and so on. I would add up those angles, and I would add up the angle between zenith and the sideline, straight line connection between the two stations. So if the Earth is a globe, and the horizontal angles, they will add up to be more than 180 degrees, and the angle between zenith and sideline, straight line, will add up to be more than 180 degrees. And if
Bro, you got 18
verticals,
trillion. You got $18 trillion. You're going to do reciprocal zenith measurements?
I mean, that's what I could. That's what I would be able to do personally, and that would be the best way to do it. And I would.
Forget personally, you got $18 trillion. You can hire a whole team of monkeys to work around the clock on this for years.
Okay. Cool.
Do you have anything better than that, or?
I mean,
it's the best you got, bro.
what's wrong with it?
That's all you got.
What's wrong with
It's
it?
flimsy. It's a little flimsy
Why
for
is
what
it
I was looking
flimsy?
for. I was looking for
Why is
something
it
kind of
flimsy?
tangible. Because I was looking for something kind of
Okay.
like tangible, something rock solid. You know what I'm saying? You're going to do a refraction calculation. I don't know.
What's not rock solid about it?
It's a calculation.
Like,
It's not even a.
It's not a calculation.
Hey, you're about to
It's a
calculate the
measurement.
refraction. No, you're going to calculate the refraction.
And measure it.
If you were going to measure it, you would have something tangible next to it so you could see where the actual thing was to get an actual position.
I'm sorry, how do you touch light?
Well, you don't touch it, but you could make a tangible, like force the line kind of object, and then you could,
That would be
line
inherently
something up.
verbs.
What would be worse?
It would be inherently worse method. It would be subject to more errors.
Yeah, but with your thing, you don't even know where the light's going.
I do. That's why I measure the ambient. That's why I have the grid of ambient conditions. I measure those. I measure the
No, but that
refraction. I don't
doesn't tell you.
calculate it. It does.
No. You're calculating. A measurement of refraction would be something tangible, and then you could see where say you have something 6 feet above level, and you're 6 feet above level, and then you're looking at it from miles away. You could get the temperature, pressure, humidity, and then calculate where it is, or you can make some kind of force aligned tangible thing, and then actually see where if the thing is appearing higher or lower than the tangible thing you made. You see what I'm saying?
How do you measure a speed? Just
How do I
speed of
measure a
anything. How do you
speed?
measure it? Yeah, how
We're
do you
not trying to
measure
measure
speed of
speed.
anything?
We're not measuring speed.
Humor me, please.
You calculate it,
Oh, you calculate it.
but we're not
Would you
measuring
say
speed,
that
though.
you?
Yeah,
Okay. So we can't ever know the speed of something because it's always just a calculation. It's always theoretical.
the speed of something isn't in contention right now, though. What is in contention is if Earth's curving or not. Like, I'm not worried if my car
Yeah,
is doing
but
60 miles an
is
hour. No one's
reflection itself
questioning that.
is the knowledge of refraction itself in contention? Because the refraction index is empirically known. You know, you can measure that. Different, like you can have like test tubes of air, and you can have like defined incremental conditions in it.
Yeah,
You can
in a
measure.
lab over short
But
distances, yeah, I would. In a lab over short distances, I would say, yeah, it's not in contention. However, long distances on Earth, it's definitely in contention.
Okay, but it's in contention because you don't know the exact conditions along the way of deciding, right?
No, that's not it. It's in contention because you don't know which path the light is taking. Even if you did know the
Yeah, and why
temperature,
do you
pressure,
not know
and
that?
even if you did know the temperature, pressure, and humidity readings, you don't know if there's some kind of effect taking place in between you and the thing you're looking at.
Okay, so if you take a little bit of air and you investigate the refraction index of that air in a lab over a short distance, so that you know which conditions correlate with which refraction index,
Yeah,
then
well,
that's not in
that's
contention. But when that air is released out in the wild, there might be something else happening to it. Strange,
yeah.
weird,
If that's what we're
weird
gonna
way of
do,
viewing this.
if we're gonna make our worldview based on little things over short distances in a lab, then you guys are fucked. Because we can take some water and we can measure that the water's not curving. We can hang some plumb lines in the
Oh my
lab and
god.
we'll see that the plumb lines aren't diverging. Like doing things over a short distance in the lab would not be the
You're
way you
moving
want
the
to
goalpost.
progress.
You're deflecting. You're deflecting, and
No, I'm
it's
showing
bullshit
you
in a
how
way of
bad of
just
an idea
pointing out.
this. No, I'm just showing you
No,
how
it's
bad
not
of
a
an
bad
idea this.
idea. No, you're not showing it. You're deflecting. You're
I'm not
deflecting from the
deflecting at
point I
all.
was making. You were acting like a reflection is in contention when it's happening, when the air is happening to be around our air. But when we isolate that air and measure its refraction index, it's not in contention. Now, when
Yes,
we have
over
that
long
sample,
distance.
when
Hold on, man.
Jeremy,
Over long distance, it absolutely is in contention. We wouldn't be here if it wasn't in contention.
why is it in contention?
Because you don't know all the effects that may or may not be taking place in between you
What
and that.
effects would that be?
There could be magnification happening. There could be something happening
Okay.
with the light that's affecting the light that's making it take a
Due to
different
what?
path than you think based on your short little lab measurement.
Due to what? What could make it have a different path?
Dude, I don't know. You don't know how light works? You know how light works?
Okay. So what I'm saying, well, maybe you're forgetting that. What I'm saying is, we know all the way, like up and down and side to side. We have a grid of measurements. We know at every point, right, within like a 10 by 10 centimeters cubes. We know the exact temperature, the exact pressure, the exact humidity. We know that at every point around us. Usually we don't, right? There's fluctuations in the air and everything. And we're along long observation side. We don't typically build a grid along it to know all of those things. That could make it have different light paths that we don't know of, which those variations on the way. But when we know it, because we measure the ambient conditions at every point along, in small distances, small increments, then we know for a fact what the distribution of the reflection indices is going to be along the way. And then we know for a fact what path the light's going to take. Unless
okay, what if the light's
you say,
what if the light's getting magnified, and that's not in your
light is
your
getting
temperature?
magnified.
What if there's a magnification happening in between you and the object, and you have these temperature, pressure, and humidity readings, but you're obviously not factoring for the magnification part of it.
Due to what would the magnification occur? Light being magnified already shows that you have a very poor understanding of this topic, but let's roll with it. Due to what would the light get magnified, as you say?
Well, maybe it's the same thing Andrew Thomas Young's talking about when he says there's atmospheric magnification happening. You know who Andrew Thomas Young is?
And
do you know who Andrew Thomas Young is?
Answer the question, please. I do. Answer my.
I do. I asked
yes.
the question. Do you know
answer my question, please. I asked you first.
Hold on. I asked you a question
I
first.
asked
Do you
you
know
first,
who Andrew
though.
Thomas Young is?
I asked you first. I already answered you, and I asked you first.
Well, I didn't hear the answer. Can you repeat it, please? You know who Andrew Thomas
Young is? I repeatedly said yes, I do, and I repeatedly asked my question. So.
Okay, go ahead. What's your question?
Okay. Due to what would the light get magnified? What could possibly lead to that?
The same reason Andrew Thomas Young gives for his magnification happening in the atmosphere.
Okay, that would be refraction. That we would know of because refraction is the change of the light path, and we know the light path because we have the according measurements. Right? We have this hypothetical grid so that we know the exact state of the air along the observation side around us, in the air around us, for like incredible distances. So unless you're saying there's anything besides the changing of the light path due to refraction, which we would know of, there would be nothing like unconsidered magnification or unconsidered things. Okay, what else would there be?
Did you know that light? Okay, did you know appear to bend?
You're roboting. I'm sorry.
The thing that happens when it's called destructive. Okay, can you hear me now?
Roboting. Yeah, it's been.
I'm still roboting.
No, it's better.
Okay, so there's a thing that they do with laser beams. There's a thing where peaks interact with peaks and troughs interact with troughs, or vice versa. I forgot the exact details of it, but light can appear to bend, but it's not actually bending. Have you ever heard of this? I think it's called constructive and destructive interference.
Interference, yeah. That would not be a problem.
Bodied some guy on Jose's with this one day.
Okay, that would not be an issue with sighting because interference with light doesn't commonly happen. You need very specific conditions for this to happen. You need very small gaps, for example, very, very small slits, and you also need coherent light sources. Right? What we observe with the light around us, it's incoherent. When you have two flashlights, right, and you shine the beams through each other, light doesn't interfere with each other. The beams go through each other, right? It's the kind of light we're dealing with
Okay,
when we
the
have
point.
sightings.
All right, bro. Okay, man. The point is, you said it yourself. You've never touched the light ray. You don't know which path the light is taking. The best you can do is guess on this whole refraction thing, and guess that there's no other things happening in between you and the object other than this basic, low level idea of what refraction does over long distance on Earth. That's all there is to it,
Well,
dude.
we can empirically measure what refraction does, right?
Not over
And
long distances on Earth, you can't. Over long distances on Earth, you can't.
Hey,
Over long
Jeremy,
distances on Earth,
wait,
you can't
yeah, I
because
heard you. I would like to
because
address
you've
it.
never touched a light ray.
I would like to address it. Thank you.
Anyways, I gotta go.
So
I gotta go because I can't even listen to this anymore. You just be going on and on forever, and I have to interrupt you every time. But go ahead.
you have to interrupt me. Interesting that there's some pressure to have to interrupt.
Yeah, because you never stop talking. But go ahead.
I see. Good thing to know. Where are we? All right. We don't exactly know what the light path does over long distances because we don't have the exact ambient conditions at every point over that long distance. There's fluctuations in the air. Air is turbulent. But if we have that given information, then we know what the light path is going to do because over short distances, we know that air is very homogeneous. We can have like little sample volumes. We know that air forms parcels. We can empirically and experimentally verify. We also know what light does through air over those sampled conditions individually. We also know that empirically, and then we can piece it all together when we have the information for all the air conditions all the way around us, and we would know all the light paths around us. We don't usually have all the air conditions at every point all the way around us, and therefore we don't exactly know what the light path does.
Okay, so if we're going to take what happens over a short distance in a lab and then extrapolate it out into what's going on in Earth over long distances, we can just go measure water not curving, extrapolate that out over long distances, and find out that water's not curving. Or we can hang some plumb lines in the lab and extrapolate that out and find out that plumb bobs aren't diverging and converging.
Yeah.
That's what you want to do?
If we find you're wrong. Finally getting to that. So you're wrong about this one because with knowing the air conditions and what light does or for a certain ambient conditions empirically by measuring it over a short distance, and then piecing it together by knowing at every location what the ambient conditions are along the way is not the same as extrapolating, like taking a short distance measurement and then just continuing the line. We are taking many measurements in many small steps along the sideline. And if we had all the information of the ambient conditions around us, it's not the same thing as just taking as just like sampling a short distance of it, then extrapolating it. That's what we would currently do. Currently, we're just saying like, okay, we have in the middle we have one station at the observer location. We have one station, and maybe at the target location we have one station. That's the most I can find for stuff that I can dig up, right? And for that case, we don't exactly know what the light path does. Just the same, we also need to recognize the limitations of accuracy that we have. And what we can't differentiate with the plumbers and measuring the water in a lab over short distance. Because what we're actually doing with the air, with what I proposed, with knowing the light path, is we're taking many different measurements, so that we have not one sample that we extrapolate. We have a sample of every little bit, so we know every little bit specifically. That would be the same with the plumb bobs. That would be the same as hanging thousands of plumb bobs and looking at them from side on with like a telescope, with like a huge resolution, so that we can really see the smallest tiny change in orientation or over those hundreds of thousands of plumb bobs.
Do you think it was fair to talk
Not
that
just
long?
two.
Oh, you're still going? My bad.
Did you even attempt to listen?
Yeah, I'm trying. I was trying. Yeah, you went on for a
Okay,
very long
good.
time though. So here's the thing.
Sorry.
Yeah, here's the thing. You're measuring what light's doing over a short distance, and then extrapolating it out into the real world
No.
over a long distance. No, that's not what you're doing. So you're measuring it what it's doing over a long distance.
I'm measuring it, but it adds up to a long distance, but I'm measuring it in very small increments along the way, all the way along. So each measurement is for a very short distance. It's not a sample
But the
that's
only
extrapolated. Each and every little piece, little progression of it, each and every little little distance is measured itself. Not a sample that's extrapolated. Every point is measured itself.
You measure the refraction in the lab, and you figure out which way the light's bending and by how much, right?
Measure? No, I measure which conditions lead to which refraction index in a lab, so that I have the information that I need to make the measurement out in the wild and measure each little bit of it and piece it together. Not taking a small sample and extrapolating it. Measuring every little bit of it, and I know what every little bit does by measuring it. I have isolated conditions and know which conditions in a lab and know which conditions conform to which path.
Yeah, well, that's pretty impressive because I got Zanuck to admit he can never get an actual position on something, but I guess you can. But anyways, what you do is you measure what
I'm
the
not saying
light's
I
doing
can.
over a short distance. Yo, why are you cutting me off, dude? You go on and on for 5 fucking minutes, bro. Let me talk. You measure
You forgot your own hypothetical.
You measure how the light's bending over a short distance in a lab, and you're like, oh, look, this is how light bends in the atmosphere. Then you extrapolate that out over a long distance and over miles and miles of Earth's atmosphere. Yes, that is what you're doing. Yes.
No.
Yeah.
That's not what I'm
Yes.
describing. That's not what I'm describing, Jeremy.
Well, how do you know how much the light bends?
Oh, God. And knowing
How do you
the
know how much
ambient
the light bends?
conditions at every point along the way.
Okay, and how did you come to that date? How did you come to that idea of how much the light is bending? By measuring it in a lab or no?
Yes, but that's not extrapolation.
Okay, so you measured it in a lab over a very short distance. Now I'm going to do the same thing with water, and now I'm going to do the same thing with how much water bends or how much plumb lines diverge, and we're going to find out that they don't.
I already gave you the analogy to that. Dude.
There's no analogy needed. I gave you the exact scenario. No analogy
needed. Oh my fucking
needed.
God, you're stupid.
Well, you can't call names.
I'm not calling names, I'm just making an observation. I already explained this to you.
Terrible observation.
How so? Look,
because I'm not
Jeremy,
stupid.
Jeremy, know you know of friction coefficients? Can you relate something with that term?
Sorry, what did you say? Friction coefficients?
Yeah.
What about
Heard
it?
of that before? So you heard of that before?
Yeah, what about it?
Okay. You know that we don't actually predict those?
You don't actually what?
We don't actually predict those. Friction coefficients are still measured empirically, like material against material with highly controlled test weights and orientations. And each is measured separately. We're just measuring it.
You
I mean, we are
measure the
noting
friction
it down.
coefficient of two surfaces.
Yeah.
What's the point?
Yeah, you're measuring the friction coefficient of one surface against the other. You measure it, you note it down. Then, when, for example, the time comes um, for figuring out if a train has enough traction or how much weight the train can pull according to the traction and stuff, or according to the friction it has and stuff. Pull up the measurements that you have from a lab on a small scale. You plug them in to the numbers for the train. Now you're not extrapolating, you're transferring. You
Sure,
have
sometimes
acquired the knowledge of the friction coefficients empirically on a small scale. Then you're using that knowledge appropriately by correctly applying it and correctly transferring it. And that's what I'm describing to you with the ambient conditions and what the resulting lag path is.
all right, sometimes you can scale things, sometimes you can't. Are you familiar with this thing called the scaling fallacy?
I'm not okay.
Are you familiar with the scaling fallacy? Yes or no?
Actually, I've not heard of that one.
Okay, well they generally use ants in this fallacy. An ant can lift, I don't know, 50 times its weight or some shit, right? You ever heard of that?
Okay,
Have you ever heard of that? An ant can lift 10 times its
I've
weight
just
if you
read it
move
up.
it.
So
What's up?
just read it up, but yeah.
You just read it up?
I
didn't hear
just
you.
read up on the scaling fallacy, but yeah,
Oh,
I have
okay.
heard of the ant thing.
Well, it's probably in whatever you're reading because that's the only thing I've ever seen used in the scaling fallacy is the ant. But
Just saw this. I just read the description of it itself, not the example. But yeah, I get it. But what I'm saying is not a scaling thing. If the friction coefficient, okay, it's a scale, right? The transferring involves often scaling it up, right? Down, depending. But what I'm describing is simply, well, I use this example of friction not for the scaling. I used it for making it more clear to you that what I'm doing with and using the knowledge that's empirically acquired about how how the air conditions depend on its refraction index, that's acquired empirically on a small scale in a lab with controlled environments, that I'm transferring it. I'm not extrapolating. I'm transferring it. I'm taking that outside, and I still know that all around me is air. Right? I still know it's all mixed through. There's no. I know it's the composition of the gases didn't like suddenly change or doesn't like suddenly make something weird. Right? So I can use the knowledge from the small scale of how the refraction index of the air depends on its ambient conditions in reality, and I can just set up a grid, a dense grid of ambient conditions measurements all around. And then I would know all the light paths. That easy. in reality. There.
You just talking to me then?
Maybe I'm just.
Yeah, hello?
We can just. Yeah, if you're here. I didn't say in VC when we chatted last before that Wolfie, we discussed temperature findings. We discussed that Wolfie didn't look into refraction. And yes, I actually also mentioned that we didn't specifically address the temperature itself. That he didn't say anything about it. Small detail.
Yeah,
I guess it got mixed up.
when we were talking before, you said that we discussed that in our text messages or our messages, sorry, but we actually didn't discuss it, so we didn't discuss anything about Wolfie and
distinctly remember that we did go through the fact that Wolfie did not point out the fact that there's a mirage, and he did not discuss the refraction that he's observing in this observation that he should be discussing, and that we did not specifically talk about temperature gradient.
No, there's nothing there about temperature gradient.
Exactly. But there is something there about him discussing refraction, the mirage. And the refraction that he should be discussing.
Yes, but in our conversation, you did mention that, like when we were actually talking earlier, you did mention that we went over the fact that he hadn't used the temperature gradients, and we had not done that. But yes, we did go over him saying, or like we did mention that he hadn't included the inferior mirage.
I also posted a comment on his video because he does have those oversights in there, which is actually really weird. That he just subtracted the tower height from the focal height and took this as the elevation of the base. That's wrong. So he did not sufficiently discuss the refraction that he would expect to occur. So it's also wrong.
Yeah, and we both know that, like, I don't think that Wolfie's stupid. He's obviously a smart guy. So why is he deliberately using things to show his observation matching what he is saying that the globe prediction is?
Okay. Well, maybe
I mean, we can't comment on his personal beliefs and thoughts, but you have to think about that. Why is he deliberately missing information out when we both know? Well, I don't believe that he's stupid. I believe he knows a lot of the mathematics behind it. He's definitely not dumb. And I think that he could have worked all that out and included that.
Right. Do you realize that when you're saying deliberately, that you're already speaking for his point of view?
Well, I said that I don't believe that he is stupid enough to not know those things. Therefore, I think I think that he's deliberately leaving it out. That's my personal opinion. I'm saying that's my personal opinion. I can't know whether or not he did it deliberately, but
yeah. Okay, but you just now multiple times said it. Why is he doing that deliberately? Which actually implies that you already know it's deliberately. So,
it's just my opinion. My opinion is that he's doing that deliberately.
Okay. One thing to consider is that you don't have to be stupid in order to make those mistakes. Very smart people make very stupid mistakes sometimes, and he could just be sloppy. He could just be doing this nonchalantly. I mean, his tone definitely is misleading them because he presents this as a fairly well-grounded kind of thing he does. That's not being completely honest and transparent then, but that could also be due to his ego then. I don't think you need to be malicious and do this deliberately in order to make those mistakes, even if you're smart and know I have a lot of knowledge.
Yeah, well, when it comes to the inferior mirage, if you actually go through some of the comments in some of his other videos, he actually mentions that another YouTuber had pointed out the inferior mirage in one of his other observations, and he just says that's irrelevant. So he's not taking these things into consideration. He just says it's irrelevant. But we know that it's not irrelevant. It obviously has relevance.
Well, another video refers to the response that he made to now refers to another video where the point he was making was a different one, to be honest.
Yeah, I'm talking about it. If you look, I mean, I'd have to find the video or whatever, but there's comments made, and basically he's commented back that, you know, he doesn't need to worry about the inferior mirage.
Okay.
So that's where I think that it's a little bit deceptive, because obviously you do need to take the inferior mirage into account. So therefore then that's where I get my thoughts on the fact that I think that he's doing it deliberately, because if it's been pointed out to him and he says, well, no, I don't need to worry about that, and just disregards it, then he's deliberately leaving it out. Even if he feels that it's because he doesn't need to. Obviously, at the end of the day, you do need to. If you want to be accurate, as you know, you have stated, if you want to be accurate about these things, obviously you need to take all these things into account. There's another one of his videos where he just pans past some ships that are like severely in like a severe inferior mirage, and just goes, yeah, and just comments on how we have ships over there underneath the horizon. So he's not taking these things into consideration. And to me, then that's just being a little bit deceptive, not taking that into consideration.
At this point, it's hand waving, but they're also have not like done. I didn't dive too deep into every video because I'm more interested in trying to potentially change my perspective, my view on things. And if it's already aligning anyway, I'm not really relying on him information anyway, because it aligns with what you get instructed with in school and so on, and what you get you can read up on yourself, you know. So you really need to go through everything that he posts in order to
Yeah, I'm
hope
just
for
looking
new
at
information.
Yeah, I'm just looking at those observations, his observations of Bathurst Lighthouse. Because, you know, like I think that I wouldn't be surprised if that he does have observations from lower down that show a hell of a lot more land and he hasn't shown them. That wouldn't surprise me because, like I said, I personally have observations at further distances where you can see almost to the very bottom, maybe only 2 meters missing at most, and it's from a lower observation than what he is doing. And then I have it where, you know, it would show even the entire lighthouse blocked from that distance. So, you know, and in one of his videos, he says, oh, you just need to show all the land underneath here visible. Well, I can show that in a different example. But I wouldn't be surprised, and again, this is me speculating, that he actually does have videos where it's shown more. He just isn't releasing those. But I could be wrong. That's just my personal opinion. Because I've been looking around for it, which I can't find, but I do know that there has been someone else who posted a video from only around 2 meters high, and there was a lot of land showing at the bottom. But I can't find that video anymore. That's land of Bathurst Lighthouse. That's from his observation. But I don't live in WA, so I can't get that footage. I can only get the footage from where I live, and I can demonstrate what he's asked from further distance and from a lower observation height. See how much better this conversation is, AK? No monologuing, no interrupting each other. Everything's so much nicer like this.